Hey guys, tonight we're going to do something your brain secretly loves and hates at the same time. We're going to think about absolutely everything by starting with nothing. You're lying there, maybe on your side, feeling the weight of the pillow under your head and the quiet around you. And somewhere behind your eyelids sits that question that has bothered human beings since we first looked up at the night sky. How can something as huge as the universe come from nothing at all? So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop your city and your local time in the comments, so we can see this sleepy little universe of night owls watching together from all over the world. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You don't have to move. You don't have to solve anything. You're just here, breathing in and out, while we very gently poke at this enormous idea. Somewhere outside your window, the universe is doing its usual dramatic routine. Galaxies drifting, stars burning out, new ones being born, black holes stretching space like taffy. And then there's you, scrolling YouTube in bed, wondering whether the whole show started from some kind of nothing, like an empty stage before the play. It sounds simple. Before the universe, there was nothing. Then, boom, Big Bang, opening scene. But already your brain quietly objects like, hold on, what do you even mean by nothing? Think about how you use that word in daily life. You open a fridge, it's just soy sauce and a lemon that's died 3 times already, and you say there's nothing to eat. Or you stare at your bank account after a long month, and it feels like there's nothing there. But, of course, that's not real nothing. The fridge still has air, the bank still has a few lonely numbers, your room still has space, dust, that one sock you can never find until you don't need it. Every day, nothing is always secretly full of stuff. Now, let your attention slide to a deeper kind of nothing, the one people imagine when they think of the Big Bang. You might picture a black, endless emptiness, silent and cold, and then a sudden explosion of light and matter bursting into that blank canvas. It's a very cinematic picture, and Hollywood loves it, but there's a quiet problem hiding in there. If there was a black emptiness for the universe to explode into, that emptiness is already something. It's space. It has distance, it has directions, it has a before and after. And the Big Bang, if we take our best physics seriously, isn't really an explosion in space. It's more like the beginning of space itself, stretching and swelling out of a state that is so unlike your everyday experience that nothing is the closest wrong word we have. You're still just lying there, but mentally you're doing this impossible thing, trying to imagine a time before time, a space before space, a state where the usual categories your brain relies on simply don't apply. When you imagine nothing, you probably see darkness, but darkness is already a visual thing. It's the absence of light and space in front of you. Close your eyes and focus on the behind your eyelids black for a moment. That too is something. It's your brain's rendering of no visible input, not the literal absence of reality. The universe doesn't give you pure nothing to work with. It always sneaks in some structure. So when cosmologists say the universe began in a hot, dense state, expanding from an almost unimaginably tiny region, they're not talking about a fireball hanging in empty space. They're talking about all of space being in that ultra-dense, ultra-hot condition. There's no outside for it to expand into. The distance between any 2 points grows with time, like a pattern drawn on a balloon as you blow it up. You never have to ask, what is the balloon expanding into? Because that's not how the math works. And yet, lying there with your cheek on the pillow, it's almost impossible not to ask, okay, but before the balloon, before the universe, really, honestly, what was there? Was there literally nothing? There's a quiet, slightly annoying truth here. The word before might not even make sense when you push all the way back to the Big Bang. Time, as far as our best theories say, is part of the same fabric as space. If time itself comes into existence with the universe, then asking what happened before the universe can be a bit like asking what's north of the North Pole. It sounds like a reasonable question in normal life, but when you zoom out, the question breaks. Still, your brain refuses to let it go. It keeps trying to point north of north, to imagine a dessert menu from a restaurant that hasn't been built yet. You might feel a tiny bit of comfort knowing that some of the smartest people in human history have wrestled with this same mental itch and not fully scratched it. Philosophers, theologians, physicists, they've all taken turns staring into this conceptual void. Some will tell you that the universe simply is, that asking why beyond a certain point is like asking why the laws of logic exist. Others propose that quantum physics allows something to emerge from a kind of fuzzy, fluctuating nothing that isn't really nothing at all, more like a restless sea of potential. And yes, plenty of people bring a creator into the story. But even then, our original question sneaks back in. Where does that creator come from? And why that, instead of nothing? Right now, you don't have to pick a side. You're not in a philosophy exam. You're in bed, letting your mind wander through possibilities it doesn't usually get time for. Feel how your body is still, how your breathing has found a slower rhythm, even as your thoughts stretch out into billions of light years and 13.8 billion years of history. You're doing something very human and very ancient, using a tiny, fragile brain to try to grasp the origin of everything. The fact that this question bothers you at all is already a clue that you're not wired to be satisfied with easy, because it just did answers. Imagine, for a moment, rewinding the universe like a movie. Galaxies rush together, clusters merge, stars unexplode back into gas, planets unswirl back into disks of dust and rock. The Milky Way shrinks into a bright, compact cloud, then into something smaller and denser still. Keep going. All the matter that will ever form stars and planets, all the radiation, all the space between everything is drawn into a state so extreme that ordinary words fail. You can't really picture it, but you can sense that as you approach that limit, asking what's outside or what was before loses its usual meaning. And yet, there's another layer to this. Even if time begins at the Big Bang, physics people are not exactly famous for saying, "Cool, we're done here." They try to push beyond that beginning with new ideas about what nothing could be. Some imagine a pre-universe state where the laws of physics are different or where there is no space and time, only some kind of abstract underlying structure. Others picture our universe as one bubble in a much bigger foam of universes, where nothing might just mean no bubble like ours yet. The story gets wild fast, but the core feeling stays the same. We're trying to explain how existence itself might be the natural thing and absolute nothingness might be the weird, unstable option. As your thoughts move around this, notice how slippery the word nothing becomes. Every time you try to grab it, it morphs into some kind of something, a dark void, an empty room, a blank screen, a silent pause. Your imagination can't make an object out of non-existence, because the moment you imagine it, you've already turned it into something. So when you hear "Did the Big Bang come from nothing?" you're not just dealing with physics. You're bumping into the limits of what your mind can represent. There's a soft irony here. You, a tiny person in one apartment on one planet around one star in one galaxy, are calmly examining the possibility that the entire universe might have popped into being from some kind of no-thing your brain can't even properly picture. Outside, someone is probably arguing about parking spaces, someone else is microwaving noodles, a cat is knocking a glass off a counter for absolutely no reason. The universe, right now, is very noisy and very specific. But when you follow it back, as far as we can, you hit this edge where language stutters and the word nothing tries to wear too many hats at once. If you feel a bit of tension between this makes sense and this makes zero sense, that's exactly the territory we're meant to be walking through tonight. You're not failing to understand. You're correctly noticing that the question itself is sitting at the boundary of what human understanding was ever built to handle. Our brains evolved to throw rocks, avoid snakes, and remember where the good fruit trees are, not to solve why is there something rather than nothing. And yet, Here you are, using that same 3-pound organ to look back toward the beginning of time, like someone using a pocket flashlight to illuminate a mountain range. It's not enough to see everything, but it's enough to feel that there is something huge out there. So, for now, you can hold on to this. When people say Big Bang from nothing, they almost never mean a clean, absolute, total non-existence in the way your gut imagines it. They mean something more nuanced, more technical, more tangled with quantum fields, curved space-time, and mathematical possibilities. They mean that our universe may have arisen from a state that doesn't look like any kind of something you've ever touched or seen. Tonight, you don't have to master the math. You just have to let yourself stand. Well, lie there, right on that edge, looking out toward a kind of nothing that might be stranger and richer than any something you've ever known. You're still lying there in the dark, with that strange aftertaste in your thoughts from wrestling with nothing that doesn't quite behave like nothing at all. Your pillow hasn't changed. The room hasn't changed. Your life probably hasn't dramatically transformed in the last few minutes. But the way you're looking at that one innocent little word is already different. A minute ago, nothing might have felt simple and flat, like an empty shelf. Now it's starting to feel slippery, like every time you reach for it, you close your hand around something instead. Think about how casually you use that word without noticing. You open your messages, no one has replied, and the notification bar is blank. You sigh and think, great, nothing. Or a friend asks what you're doing this weekend, and you say, honestly, nothing, even though if we zoomed in on your schedule, there would still be sleep, meals, scrolling, the traffic outside, the same little rituals that quietly fill the hours. Nothing in daily life usually just means nothing interesting to me right now. Picture an empty room for a moment, the kind you might imagine if someone told you to visualize nothingness. For bare walls, maybe white or gray, a plain floor, a closed door, no furniture, no decoration. Your brain might look at that and go, okay, close enough to nothing. But if you slow down, you notice how ridiculously crowded that empty room actually is. There's air pressing softly against every surface. There's dust gently drifting in the light, even if you can't see it. There's gravity tugging on your body if you're standing there. The Earth's magnetic field passing through, Wi-Fi signals slipping invisibly from one device to another. If you really want to be picky, there's the floor itself, the walls, the molecules inside the paint, the tiny vibrations of atoms that never completely stop. Even the silence in that room isn't a pure silence. There's the hum of distant traffic, the faint buzz of electricity in the walls, the soft hiss of your own breathing, the beat of your heart sounding like a slow drum inside your chest. Close your eyes and try to hear absolute nothing. You can't. Your nervous system is always feeding you some murmur of sensation. If your ears had a volume bar, they'd never reach zero. There's always some sound, some feeling, some subtle weight of being alive. So when you say there's nothing here, what you usually mean is there's nothing here that I care about, nothing that grabs my attention, nothing that fits the story I'm telling myself right now. It's a kind of lazy shorthand your brain uses, and it works fine when you're talking about the fridge or your social life. But it starts to break down the moment you try to apply it to the origin of the universe. Move your attention to another familiar kind of nothing, a blank screen. You pick up your phone, open a new note, and that empty white space looks like nothing. No words, no drawings, no reminders screaming at you, just potential. But hidden behind that clean digital emptiness is a wild stack of stuff. Circuits firing, electrons flowing, code running, servers syncing, entire data centers humming away in some other part of the world. That nothing is sitting on top of an insane amount of something. Or think about a blank sheet of paper. An artist might stare at it and groan, calling it nothing because no drawing has appeared yet. A writer might frown and say they've got nothing on the page. But the paper itself is matter. It's made of fibers, arranged in patterns, full of atoms and molecules buzzing with thermal motion. It has weight, texture, a faint smell of pulp or ink. Even as nothing on the page, it's already a very particular arrangement of reality. You use the word in emotional ways, too. After a relationship ends, you might look back at the time before that person and say, before them, there was nothing, as if your whole life started at first contact. It feels true in that moment, but it's not literally true. There were years of experiences, habits, small joys, annoyances, all the little details that made you who you were when you met. Your memory just compresses all of that into a smooth, blurry before, because the story you're focused on now has a clear beginning and end. Brains love compressing. When something is too detailed, too messy, or simply not useful, your mind wraps it in a single word and moves on. Forest, instead of millions of leaves. Crowd, instead of hundreds of strangers. Nothing, instead of nothing relevant to my current goal. 99% of the time, that shortcut is harmless. But when you bring that same shortcut to the question, did the universe come from nothing? You're smuggling in a lot of hidden assumptions. Let yourself drift through a few more examples. There's nothing on TV, someone complains, scrolling past hundreds of channels and thousands of hours of content, none of which feel appealing in that moment. I've got nothing to wear, said to a closet that might physically injure you if it fell over. I did nothing today, said at the end of a long list of tiny tasks your brain didn't bother to record because they weren't dramatic enough. Your lived experience is crowded with these exaggerations, and they're so automatic that you barely notice them. Now, try a little thought experiment. Imagine standing in the middle of your room and mentally removing things, one by one. Start with the obvious: furniture, clothes, books, devices. The bed and blankets disappear. The shelves fade. The floor is bare. Keep going. Remove the dust, the stains on the wall, the faint smell of whatever you last ate in here. Strip away the decorations, the curtains, the light bulb. At some point, your mind declares victory and says, all right, it's empty. Happy now? But if you look closer, you realize the room still has dimensions. There's still up and down, left and right, the distance between one wall and the opposite wall. There's still air, unless you deliberately imagine sucking it out. And then there's still space, a volume that something could occupy. There's still gravity curling through the room. Still the Earth's mass tugging gently at everything. Still the passage of time as seconds tick by. You can't help but imagine yourself as an invisible observer lingering in that space, which means your own awareness is still there, noticing the nothing. If you get really ruthless and try to imagine removing the air, the walls, the floor, even the planet beneath, you end up picturing yourself floating in blackness. No stars, no planets, just darkness and you. It feels like an upgrade in the nothing department, but it's still not the real thing. That black void still has space, directions, distances. You could imagine throwing a ball and watching it travel. You could imagine measuring meters or light years. You've just painted the room black and taken the furniture out. You haven't actually turned existence off. The same thing happens with silence. If you sit perfectly still and listen, there's always some background noise. Maybe it's the fan or a distant car, or the faint ringing your ears make when things get really quiet. Even if you went to a professional soundproof chamber where people can hear their own heartbeat and blood moving, you'd still be hearing something. Absolute silence. No sound waves, no internal noises, no nervous system fizz is not a thing your body ever experiences. Your version of nothing to hear is still a lot of activity, just below your usual threshold of interest. This gap between what you mean and what is actually there is one of the reasons your intuition stumbles so hard over cosmic questions. When a physicist or a philosopher uses the word nothing, they're usually trying to be careful, defining it in some specific way. When you use it in normal life, you're mostly expressing boredom, frustration, or lack of options. You're not making a precise claim about the total contents of reality. You're just saying, my expectations aren't being met right now. It's a bit like walking into a party and saying, there's no one here, when there are 10 people standing awkwardly in the kitchen. What you really mean is, none of the people I wanted to see are here. The sentence isn't literally true, but it transmits the emotional truth. This isn't what I hoped for. The word nothing is doing a similar job in your daily speech. It packages a feeling of absence into a quick, dramatic label. So when the question creeps in, did the Big Bang come from nothing? Your mind instantly pulls up these everyday meanings. The empty room, the blank screen, the quiet moment where nothing much seems to be happening. You might even imagine a kind of cosmic blank hallway, stretching forever, into which the universe suddenly shows up like a delivery you didn't order. But all of those images are already way too generous. They sneak in space, time, physical laws, and usually a point of view watching the whole thing happen. To get closer to what scientists are really talking about, you almost have to untrain that habit. You have to notice how quickly you declare nothing when reality fails to entertain you, and how weirdly hard it is to imagine true absence. Your brain is a storyteller that hates gaps. If there's a hole, it plugs it with something: a dark room, a silent void, a pause between scenes. It can't picture the total lack of stage, props, actors, and audience, because that kind of non-reality is not something it ever had to deal with while trying to survive. There's also a subtle comfort in your casual nothings. When you say, "I did nothing today," you're smoothing over all the micro efforts and worries and tiny wins. You're shrinking them into a soft blur, like lowering the resolution on a picture. That blur can be soothing. It makes the day feel simpler, less crowded. If you had to consciously track every muscle movement and every neural firing, you'd never rest. So the brain's habit of calling a quiet scene nothing is part of how you stay sane. But tonight, with your body sinking a little deeper into the mattress and your thoughts stretching further out, you're asking a question that doesn't cooperate with those shortcuts. You're asking whether there was ever a state where literally nothing existed. Not just no furniture, no TV, no notifications, but no space, no time, no fields, no laws, no possibilities. And as soon as you try to imagine it, your mind quietly smuggles something in through the back door. A dark backdrop, a sense of before and after, a witness. If you pay attention, you can feel that smuggling as it happens. You say to yourself, "Okay, imagine nothing." And an image appears, some kind of blankness. That blankness has a color, even if it's just black or gray. It has a size. It feels like a scene you're looking at. Your sense of self sits just outside the frame, observing. It's like trying to draw a picture of no picture on a piece of paper. The moment your pen touches the page, you've contradicted your goal. Gently noticing this doesn't mean you're doing it wrong. It means you're starting to see the limits of your own tools. A hammer is great for nails and useless for soup. Your imagination is great for rearranging existing things and almost useless for representing true non-existence. That's okay. You can still talk about nothing in a meaningful way, as long as you remember which version of the word you're using. Right now, you've simply taken the first step, separating your everyday nothings, empty rooms, boring weekends, blank screens, from the deeper, stranger nothing that comes up in cosmology. You can feel that your normal version of the word is more about usefulness and attention than about reality's actual contents. Once you see that, the question, "Did everything come from nothing?" starts to feel less like a yes or no puzzle and more like an invitation to ask, "Okay, but which nothing are we talking about?" As you lie there, breathing a little slower, you're already moving from casual shorthand to a more careful curiosity. You're starting to hold the word nothing up to the light, turning it slowly, seeing all the fingerprints and smudges your daily life has left on it. And that quiet shift, just that, is what opens the door to all the deeper debates and discoveries that wait ahead. That quiet realization you just had, that your everyday nothing is actually pretty crowded, puts you in very old company. You aren't the first person to lie awake, stare into the dark, and wonder if emptiness is even real or just a mental shortcut for nothing I care about right now. People have been arguing about that exact feeling for thousands of years, long before barometers and particle accelerators, with nothing but words, logic, and a lot of confidence in their own opinions. If you listen for a moment, you can almost hear them, all these voices layered on top of each other through time, still arguing about what's inside your empty room. Imagine, for a second, that your bed floats gently backward in time and sets you down in an ancient Greek courtyard. Stone columns, warm air, the faint sound of sandals on gravel. A teacher in a flowing robe looks at a group of students and declares, in a tone that leaves no room for argument, that nature hates emptiness. The phrase later gets turned into Latin, nature abhors a vacuum, and it sticks so well that people quote it like a law of the universe. For this teacher, who might as well be Aristotle in your little mental movie, the idea that there could be a region with truly nothing in it is ugly and wrong. In his view, the universe is full through and through. Earth, water, air, fire, all blending and pushing, never leaving gaps. If you remove something, something else rushes in to fill the space, like water flowing into a hole dug in the sand. If there really were a patch of pure emptiness, he argues, motion would become weird or impossible. How could things move if there were no medium to move through? How could you talk about distance if there's nothing in between? To Aristotle, your empty room is an illusion. It's just a place where the stuff happens to be thinner, not absent. Not everyone in that world agreed with him, though. Slide a little earlier in time, and you bump into the atomists, people like Democritus, who imagine reality as tiny, indivisible bits of something falling and colliding in a background of nothing. In their picture, the universe is like an endless dark theater where the stage is absolute emptiness, and the props are these little atoms dancing around, making worlds and people, and eventually, you lying in bed wondering if they were onto something. They needed the void to exist, because without it there was nowhere for the atoms to move, nowhere for structures to form. So even back then, you already had a kind of split personality around the idea of nothing. On one side, the plenum people, folks like Aristotle and later Descartes, insisting that space had to be filled with some kind of subtle stuff or reality would fall apart. On the other side, the void people like Democritus and later Newton, saying no, you can have empty space, and that's exactly what makes motion and change possible. Nobody had vacuum pumps or mercury tubes. They had debates, metaphors, and thought experiments. If you squint, it looks a lot like your brain arguing with itself every time you try to imagine nothing and end up picturing a dark, roomy something instead. The problem, for centuries, was that this whole argument stayed safely in the realm of words. Philosophers would stand in lecture halls or sit at desks, building careful chains of reasoning about whether a vacuum could exist, but they couldn't just walk into a lab, flick a switch, and say, okay, let's suck the air out of this jar and see what happens. The closest they got were everyday observations. Water climbing up pumps, flames needing air, lungs filling and emptying. And because those things seem to show that something always rushed in to fill a gap, nature abhors a vacuum, felt like common sense dressed in fancy language. Your own experience, honestly, doesn't make vacuum easy to believe either. You've never stuck your hand into a real, lab-grade emptiness. You've always been patted on all sides by air, pressure, atmosphere. From that vantage point, the idea of a patch of space with nothing in it can feel weird and artificial, like something that only exists on chalkboards. So you can almost sympathize with the old philosophers who thought real emptiness was impossible. Their world had weight and resistance everywhere. They had no reason to trust a void they couldn't touch. But the universe has this annoying habit of not caring what sounds reasonable. Fast forward your mental camera a bit, and you find people starting to poke at nothing in a new way. Not with arguments, but with glass tubes, metal pumps, and stubborn curiosity. One of the first big clues shows up in an unglamorous, practical problem. Water pumps in mines refusing to lift water beyond a certain height. No matter how hard people tried, the suction just stopped working once the water reached about 10 meters. If nature truly hated a vacuum, why was she suddenly getting lazy at that specific point? Enter Evangelista Torricelli, who who decides to play a slightly dangerous game with mercury, which is heavier than water and not exactly friendly. He fills a glass tube with it, turns the tube upside down into a basin of mercury, and watches as the level in the tube drops, leaving an empty-looking space at the top. That quiet little gap becomes famous. People stare at it and argue about what it contains. Is it a vacuum? Is it a mysterious, invisible substance? Is it God? Torricelli shrugs and suggests that maybe, just maybe, they're staring at actual nothing, or at least at a space with drastically less stuff than they're used to. You can picture yourself standing there the first time this happens, watching the silver metal slide down, leaving a clean, glassy void. After all those centuries of nature abhors a vacuum, here is a literal bottle of near-nothing being passed around like a new kind of wine. Some people are fascinated, some horrified, some offended on Aristotle's behalf. The debate starts to tilt away from pure philosophy and towards something more dangerous to cherished ideas: experiment. Torricelli's work catches the attention of Blaise Pascal, who has the energy of that one friend who hears about a weird trick and immediately wants to test it everywhere. He and others haul barometers up mountains and towers, watching the mercury level drop as they climb higher into thinner air. The space at the top of the tube grows. That means the pressure of the air above you matters, and the nothing inside the tube is not just a visual trick. It's responding to something real, something measurable. This is the moment when vacuum starts becoming less of a philosophical ghost and more of a physical condition you can create, compare, and use. Then comes Robert Boyle with his air pump, a kind of proto-sci-fi machine that lets him drain air from a glass chamber. You might have seen drawings of it: a bell jar, a mechanism, curious onlookers. Boyle removes the air and notices all kinds of strange behavior. Bells ring more softly or not at all. Flames struggle and die. Living creatures inside the jar. He used them, but we don't have to dwell on that part. Behave very differently as the air thins. For the first time, humans aren't just talking about the void. They're engineering it, turning it into something you could, in principle, order off a catalog. One vacuum pump, please, to go with my telescope. If you pause here, you can feel the tension between two ways of thinking. The philosophers want a clean concept. Either the vacuum is absolutely empty or it doesn't exist. The physicists, or the early versions of them, are okay with Messier language. They talk about partial vacuum, good vacuum, better vacuum, as if nothingness comes in grades. They care less about purity and more about what happens when you twist the valve another turn. For them, vacuum becomes a tool, a way to isolate variables, to strip away air so they can see other forces more clearly. For philosophers, that same jar is a battlefield where definitions live and die. This is where you start to see the split that still exists today between how philosophers and physicists talk about nothing. Philosophers tend to treat the word like a grenade. You have to hold it carefully or it blows up your sentences. If nothing is something, then it's not nothing. If you can give it properties, you've already cheated. So they tie themselves into careful knots, trying to avoid turning nothing into a weird ghost object. For them, nothing isn't a thing. It's the absence of all things, all properties, all structure. Full stop. Physicists, meanwhile, are shamelessly practical. To them, vacuum is whatever you get after you've removed as much stuff as you possibly can, plus or minus some quantum weirdness. It has pressure, temperature, energy density. It appears in equations. You can put a number on how empty your vacuum is and compare it to someone else's. And later, when quantum theory shows up and tells them that even the lowest energy vacuum still seethes with activity, they don't throw their hands up and quit. They shrug and say, okay, so our nothing is busy. Fine, let's calculate. Your mind, lying here, kind of contains both personalities. Part of you wants that philosopher's clarity, that sharp, clean concept that says either there's something or there isn't, no middle ground. Another part of you is much more physicist. If a vacuum is empty enough for light to travel with almost no interference, for objects to fall the way they're supposed to, for certain experiments to give clean results, that's good enough. You don't need it to be metaphysically pure. You just need it to behave predictably. If you drift from the pumps and tubes to the big-picture thinkers of the 17th century, the story keeps twisting. Descartes, for example, can't stomach the idea of a true vacuum. For him, space and matter are almost the same thing. To have space without matter makes no sense. He imagines the universe as a giant whirlpool of subtle fluids, everything filled with some kind of stuff, even if it's an ethereal substance nobody can see. In his picture, your empty room is just a less cluttered swirl of the cosmic fluid. There's no bare background waiting underneath. Newton, in contrast, is more comfortable with emptiness. His gravity acts across empty space, pulling masses together even when there seems to be no medium in between. For him, space itself is like a giant, invisible stage, a kind of absolute arena where things can exist or not exist. There can be regions of that stage with no props on them, and that's okay. The stage is still there. It's not nothing exactly, but it's a framework in which nothingness can be described. This region contains no matter, that region does. You can feel the philosophical problems bubbling under that last idea. If space itself is always present, it's not really nothing in the ultimate sense. It's more like a very minimal something, a backdrop with properties, dimensions, geometry, the ability to let objects be somewhere. So even when thinkers claim to be talking about emptiness, they often end up leaving some kind of structure in place. That's one of the subtle tricks your mind plays on you too. When you imagine the universe before the Big Bang, you often picture a dark, empty space, forgetting that space itself is already a huge something. By the time you reach the modern world, long after barometers and air pumps have become high school science demos instead of cutting-edge experiments, the argument has stretched into two almost separate languages. Philosophers ask, what do we mean by nothing at all? Is it even coherent to talk about a state where not only are there no things, but no laws, no possibilities, no structure? Physicists point at their apparatus and their equations and say, look, when we say vacuum, we mean the specific measurable state of a field with this energy level, these fluctuations. Call it something or nothing, we don't really care as long as the math works. You're lying right at the intersection of those two habits. On one side, you're curious about the deep, metaphysical question, did everything really come from the total absence of anything? On the other, you're fascinated by the practical trick of bottling near nothing in a jar, of creating emptier and emptier regions, and watching weird new effects appear. Both stories are true in their own domains. The philosophers help you keep your concepts honest. The physicists help you keep your expectations tethered to what the universe actually does when you poke it. And underneath all of that, there's the quiet irony that the more carefully you try to bottle nothing, the more interesting things you find happening inside it. Those early pumps and barometers were just the beginning. As people learned to make better vacuums and to measure more subtle effects, the supposedly empty space inside their tubes turned out to be anything but simple. The void became less like a blank page and more like a strange, restless sea. That's where your thoughts are heading now, away from dusty arguments in ancient courtyards, past early modern labs full of glass and brass, and into a realm those people could barely have imagined. Because as soon as you start looking at the vacuum not as a dead absence, but as a physical thing with behavior, you open the door to the next surprise waiting for you. That the quietest possible something might still be buzzing with activity so deep and subtle that we only learned to talk about it when quantum mechanics arrived. That restless sea you were just imagining, hiding inside the best vacuums or old air pumps could make, gets a name and a personality when quantum mechanics shows up. All those careful experiments with glass jars and mercury tubes were like tapping on the surface of something deep without knowing it was an ocean. Quantum theory basically walks over, looks at the empty stage everyone's been arguing about, and says, "You're all very cute, but this floor? It's alive." You've probably heard the word quantum enough times that it starts to sound like marketing fluff, but here it's doing something very specific. In the old, comfortable picture, you had little particles, tiny marbles, moving through a background of space. Space was the container, the particles were the content, and emptiness meant you'd taken all the marbles out of the box. Simple. Quantum field theory quietly tosses that whole picture out of the window while you're trying to fall asleep. In the new view, the basic ingredients of reality aren't particles sitting in space. They're fields filling all of space. Not a field like a nice meadow, but something more abstract, a kind of invisible value assigned to every point in the universe. There's an electromagnetic field, a field for electrons, a field for quarks, a field for each kind of particle you've ever heard of, and some you probably haven't. The universe, on this level, is less like a box of marbles and more like a whole orchestra of overlapping vibrating instruments, each one present everywhere, all the time. You can imagine lying in your bed as if you're floating in the middle of all these fields. Even in the dark, even in a perfect vacuum chamber, drifting in deep space, they don't go away. They're the background fabric, the underlying something that's there even when no individual particles are buzzing through. When you have a particle, what's really happening in this picture is that one of the fields is excited in a particular way. A photon is a little ripple in the electromagnetic field. An electron is a particular kind of disturbance in the electron field. The vacuum, then, is what you get when all those fields are in their lowest possible energy states, with no obvious ripples rising high enough to count as particles. So far, that might still sound like a fancy way of saying nothing. Lowest energy. No particles. Quiet. But quantum mechanics refuses to let lowest mean completely still. It sneaks in a rule, the uncertainty principle, and sets a limit on how calm anything can ever be. If you try to nail down the energy of something as exactly zero, the uncertainty in other properties explodes. The universe basically says, nope, you don't get a perfectly still field. There's always a little jitter left over. The result is strangely poetic. Even the ground state, the quietest possible condition of each field, still trembles. Not enough to produce steady, classical waves, but enough that tiny, fleeting fluctuations are always bubbling in and out. People call this zero-point energy, the leftover energy you can't get rid of, no matter how thoroughly you've emptied the region. If you picture the field as a stretched sheet, vacuum isn't a flat, calm surface. It's a fabric with microscopic ripples, twitching too quickly and too subtly for you to see directly most of the time. If that mental picture feels a bit slippery, try shrinking your focus down to a single mode of vibration, like one particular way the field could wiggle. Think of a guitar string that can ring at many notes. Classically, you could imagine it at rest. Not moving, no energy. Quantum mechanics remodels it into something more like a set of steps. The string can't just have any amount of energy. It has specific allowed levels. Ground floor, first floor, second floor, and so on. And crucially, the ground floor is not at zero. There's always some energy left in the off position, a faint hum built into reality's wiring. Now, connect that back to the vacuum. Space, even when you've removed all particles and cooled things down as far as you possibly can, is like a gigantic collection of these quantum strings, each with its unavoidable ground floor shake. The total effect isn't a dramatic roar. It's a delicate, omnipresent fizz. You, lying there in the dark, are soaking in this invisible background energy. You're never truly in the middle of nothing. At best, you're in a place where all the fields are whispering instead of shouting. Physicists give these whispers names like vacuum fluctuations and virtual particles, which sounds like the point where someone should roll their eyes and say they've gone too far. But the idea is simple enough. Those tiny jitters can, for brief moments, look like little pairs of particles popping into existence and then annihilating each other so quickly that they don't break the cosmic rules. They're not stable, long-lived stuff you can catch in a bottle, but they're real enough to leave fingerprints. The wild part is that the vacuum's secret bustle isn't just philosophical decoration. It has measurable consequences. Even before we get to the more dramatic experiments later, you can sneak a peek at how this restless nothing affects things like atomic energy levels. Electrons orbiting a nucleus feel not just the clean, smooth electromagnetic field you draw in textbook diagrams, but one that's ruffled by vacuum fluctuations. Those tiny ruffles slightly shift the energy levels of the atom, and we can detect that shift. It's like noticing that a building's floors are offset by a few millimeters because the ground beneath it is subtly vibrating. If you tilt your head just right, you can feel how rude this is to the old philosophical idea of nothing. Remember those people who wanted nothing to mean the complete absence of anything, including laws and possibilities? Quantum vacuum laughs at that. It's not absolute absence. It's a very specific something. The lowest energy state of a given set of fields obeying particular rules. You can write equations for it. You can plug in numbers. You can predict how its fluctuations will influence the things you can actually see. This nothing is about as far from metaphysical emptiness as your supposedly empty room was from being truly void. And here's where your mind has to juggle two layers at once. On one level, the vacuum is incredibly empty compared to your daily world. No air, no dust, no stray photons bouncing around. A cosmic vacuum makes the best laboratory vacuum look like fog. Compared to a gas, it's a desert. Compared to liquid or solid matter, it's practically a ghost. So from that everyday perspective, calling it nothing kind of works. You're acknowledging that there's no ordinary stuff left. On the deeper level, though, that desert isn't really bare sand. It's a hidden ecosystem. All those fields, all that zero-point energy, all those jittery fluctuations form a baseline structure without which the rest of physics would make no sense. You can't switch them off. You can't peel space away from them. In fact, when you say space, at this stage, you almost mean the network of fields and their vacuum state. The stage and the orchestra blur into a single thing. That thought, lying here in the dark, quietly blows up the picture you started with back when you imagined nothing as a black screen. That blackness wasn't nothing at all. It was at least space, and in this richer view, it's space plus structure, plus laws, plus fields. Your mind keeps wanting there to be some deeper layer where everything is actually absent, where even the possibility of fluctuations is gone, but physics, so far, hasn't taken you there. It stops at the vacuum and says, this is as empty as our equations can get, and even here there's activity. You might wonder, while your pillow slowly warms under your cheek, whether this vacuum energy has any larger role to play than just making life slightly complicated for people calculating atomic spectra. The answer, annoyingly, is yes. Those restless fluctuations and the way fields settle into their ground states might be tied to some of the biggest puzzles in cosmology, the way the universe expands, the mysterious push of dark energy, the initial conditions of the Big Bang itself. The tiniest jitters of nothing might be entangled with the largest structures you can imagine. Think about how upside down that is. You go hunting for nothing and find a fabric that participates in everything. Galaxies drift apart against a backdrop that isn't just an empty grid, but a dynamic medium whose properties matter. The vacuum, once a side character in philosophical arguments, turns out to be a central player in the story of why the universe looks the way it does and why it behaves the way it's currently behaving. Your sleepy question about whether something can come from nothing starts to sound a bit different. Maybe the nothing you're picturing is already a kind of seed. Of course, you can also hear a little alarm bell going off in your head, telling you not to cheat with words. If you define nothing as a stage full of quantum fields obeying precise laws and carrying unavoidable energy, then calling that nothing is like calling your fully furnished bedroom empty because you put your phone away. This is where the philosophers from earlier would jump back in and wave their hands, insisting that you're playing fast and loose with the concept. They're not wrong. From their stricter viewpoint, the quantum vacuum is absolutely not nothing. It's a very particular kind of something with an entire instruction manual attached. Physicists, meanwhile, kind of shrug and keep going because for them the vacuum is the useful baseline. It's the thing you compare everything else to. You measure the energy of a particle or a field configuration relative to that ground state. So in a language, nothing often means no particles above the vacuum. It's a practical shorthand, not a philosophical statement. Your brain, lying here, has to learn to translate between those two dialects. Everyday and experimental nothing on one side, and the stricter, almost impossible nothing that has literally no properties at all on the other. As you get more comfortable with the idea that the vacuum is busy, another feeling creeps in, a kind of quiet awe at how delicately structured the universe is, even when it's supposedly at its bare minimum. You didn't ask for quantum fields. You didn't vote on the value of their zero-point energy. You were just born into a reality where off still hums and empty still seethes. That's the baseline from which planets, stars, and life have to emerge. When people talk about the universe being finely tuned, sometimes they're pointing straight at this deeper layer where the knobs are set in ways we still barely understand. You can let that thought settle under your ribs for a moment, that when you lie in the dark and think you're surrounded by nothing, you're actually resting on top of the most fundamental structure we know, a restless nothing that's not nothing, stretching in every direction. The atoms in your body, the photons bouncing off the walls, the gravity holding you against the mattress, all of it exists on the scaffolding built by these fields and their vacuum states. You're like someone floating on a calm-looking sea that hides miles of swirling currents below. And if even the vacuum refuses to be truly empty, what does that do to the story of the universe's beginning? If the quietest possible state of the field still has energy, still has activity, then maybe the question isn't, how do you get something from nothing? But how do you coax a universe out of the lowest, jittery baseline it already had? That's the direction your thoughts are drifting toward now, away from the microscopic ripples in the vacuum and toward the grand, sweeping expansion that turned those ripples into everything you see. To trace that path, you'll have to zoom out from this quantum sea and start rewinding the cosmic movie, watching galaxies, clusters, and the web of large-scale structures shrink backward, converge, and heat up until they're compressed into conditions so extreme that even our best theories start to sweat. The vacuum that wasn't empty, it turns out, might have been the starting canvas for a universe that was once unimaginably dense and hot, a far cry from the gentle darkness wrapping around you tonight. When you start to think about how that restless quantum vacuum could possibly be linked to the vast universe outside your bedroom, the only honest move is to zoom out. You let go of the tiny jitters hiding in every point of space and pull the camera back in your mind until you're sitting not just in a room, not just on a planet, but inside a galaxy swimming in an enormous cosmic ocean. You imagine lifting straight up, through the ceiling, past the rooftops, higher than planes fly, through the thinning air, until Earth is a glowing marble and the stars stop being a flat wallpaper and start showing their real depth. From that vantage point, the universe suddenly looks like it's doing something simple and dramatic. It's expanding. Galaxies aren't just hanging there. Most of them are drifting away from one another, the distances between them stretching like the fabric of a slowly inflating balloon. Astronomers figured this out by looking at the light from distant galaxies and noticing that its colors were shifted toward the red, stretched out like a siren's pitch dropping as it rushes away. The farther a galaxy is, the more its light is stretched, the faster it's retreating. Space itself is in motion, not with a bang, but with a stubborn, ongoing swell. Lying here, you don't have to memorize anyone's name or equation to feel the shape of that discovery. All you need is the image of a movie that's currently playing in one direction, Galaxies drifting apart, the universe growing larger, the average distance between clusters increasing as the ages roll by. Now, because your brain is annoyingly good at playing with time, you put a finger on the mental tape and drag it backward. Everything you just watched in slow expansion begins to run the other way. Galaxies that were drifting apart slowly begin to edge closer together. The immense gaps of nearly empty space between clusters begin to shrink. Those great cosmic filaments of galaxies that stretch across billions of light years tighten like elastic bands, drawing mass inward. What looks almost static on human timescales reveals its motion when you fast forward or rewind over billions of years. The familiar night sky above our neighborhood would be unrecognizable if you could jump back far enough. Constellations would twist and dissolve as stars orbit their galactic centers and the whole galaxy falls inward toward others. As you rewind, you can feel the air in your imaginary movie grow thicker with matter. Not literally air, but the density of stuff everywhere. Right now, if you picked a random cubic meter of space between galaxies, you'd mostly find nothing, just a few stray particles and a thin drizzle of radiation. Run the clock backward, and that random cube becomes busier, more crowded. The average density of the universe rises. Everywhere you look, more matter in the same volume, more energy squeezed into less space. Temperature follows density like an overly attached friend. In the real universe, when gas clouds collapse under gravity, they heat up. Compress air in a bike pump and it warms. Compress an entire universe, and it becomes ridiculously hot. In your mental rewind, the cosmic temperature climbs. The gentle cold of deep space, a few degrees above absolute zero, gives way to a warmer glow. Keep going, and that glow becomes a blinding, searing brightness filling all of space. There's a point in this rewind where the galaxies you started with are gone, not because you've erased them, but because you've gone back to a time before any of them existed. Stars haven't formed yet. There are no planets, no heavy elements, none of the complicated chemistry that temporarily organized itself into you. Instead, the universe is a thick, hot soup of simpler ingredients, mostly hydrogen and helium, maybe a sprinkling of lithium, all jostling in a chaotic plasma where electrons haven't had a chance to settle down into stable orbits around nuclei. It's like watching a building deconstruct itself into piles of bricks, then into dust, then into a shimmering cloud of raw materials. If you let the tape play backward further, you arrive at a strange moment that we actually have direct evidence for, even though it happened billions of years before you were born. There's a time when the universe is still hot and dense, but just cool enough for electrons and nuclei to finally pair up and form neutral atoms. When that happens, light that had been constantly scattered by charged particles is suddenly free to travel. The universe goes from opaque, like the inside of a star, to transparent, like a clear morning sky. The glow from that moment is still around us, stretched and cooled by expansion into what we now call the cosmic microwave background. If your eyes could see microwaves, the entire sky would shimmer with a nearly uniform, ancient afterglow. In your mental rewind, that afterglow sharpens and brightens. The microwave background becomes a fierce, fiery light, then an unbroken blaze as you go back to the time before atoms, when the universe was too hot and energetic for anything stable to form. You're watching history not as a calm sequence of events, but as a continuous change in temperature, density, and structure. Each backward step takes you to a younger, hotter, more uniform universe. The clumps and clusters smooth out. The intricate web of galaxies dissolves into something more like a fog. The fog thickens. The fog heats. Somewhere behind that fog, the concept of a galaxy stops making sense entirely. This is where the metaphor of a tape is helpful, but also a little sneaky. When you rewind a movie, every frame is still clearly drawn. People walk backward through doors, cars uncrash, explosions suck themselves neatly into grenades. The physics of the video itself doesn't change. Only the direction of playback does. With the universe, something deeper is happening. When you rush back toward the earliest moments, you're not just undoing events. You're racing toward a regime where the physics itself may not look like the familiar rules that let you predict how a ball will fall or how a planet will orbit. Still, you push the tape farther back because your mind is stubborn. You let the temperature rise until it's so high that even protons and neutrons can't hold together. The simple atoms that were barely hanging on dissolve into a soup of quarks and gluons, the fundamental bits, and the glue that holds them. Space is no longer filled with stars and gas and dust. It's a uniform, roaring plasma of the most basic ingredients we currently know. Any structure you try to imagine melts into an intense, featureless fireball. At this stage, where and when start to feel wobbly. In your normal life, you talk about locations and times as if they're simple. Here, there, yesterday, next week. In this extreme rewind, the distinction between different places in the universe becomes fuzzy because everything is so uniform. Any point in that early fireball looks pretty much like any other. You're not zooming toward a central explosion. You're compressing everything everywhere at once. There's no empty outside, no quiet background watching from a safe distance. The entire canvas is involved. Gravity, which on human scales mostly just keeps you on the mattress, takes on a different personality here. In the expanding universe you started with, gravity is constantly fighting the tendency of space to stretch, pulling matter together into galaxies and clusters even as the overall fabric grows. In the rewind, you see that battle in reverse. The expansion slows, the pull of gravity becomes more apparent, everything crowds closer, the energy density spikes, and the curve of space-time itself starts to twist more dramatically. It's not just the contents of the universe changing. The geometry they live in is changing too. Somewhere very close to the beginning. At least as far as our current theories can push, the numbers you'd write down for density, temperature, and curvature blow up. They head toward infinity, which is physics' way of waving a white flag. When the equations that normally do such a good job suddenly produce infinities, it usually means not that the universe literally hit an infinite value, but that your description has stopped being adequate. You've pushed the map to a place where it no longer matches the territory. You can feel that limit even lying here, just by noticing how your mental images start to fail. You can picture galaxies crashing toward one another. You can picture stars dissolving, atoms shredding, particles swimming in a blinding soup. But what does it even mean to imagine a universe where space and time themselves are so warped that you can't sensibly talk about before and after in the way you're used to? That's the edge of the tape, the point where the footage runs out and all you've got is a frayed end and a lot of questions. The Big Bang, in this picture, isn't a bomb going off at one spot. It's more like the starting frame of your tape, the earliest moment where our current laws can still say something coherent. Everything you see now, your room, your body, the galaxy, the cosmic web, comes from letting that initial, dense, hot, nearly uniform state evolve forward for billions of years. In rewind, everything collapses back into that state. Forward, the intense fireball cools, structures form, stars ignite, planets condense, chemistry wakes up, and eventually a tired human ends up lying in bed wondering if it all came from nothing. There's a quiet strangeness in realizing that from the perspective of the universe, you are very, very late to the party. Most of cosmic history happened before any living thing you know existed. When the cosmic microwave background was released, there were no eyes to see it. When the first stars lit up, there were no minds to be impressed. When galaxies swirled into their graceful spirals, there were no poets to compare them to whirlpools or seashells. All of that happened long before your tiny local story began. Yet in your imagination, rewinding it all feels effortless. You float through billions of years like skipping back a few seconds in a song. As you sit with that feeling, you might notice how the idea of coming from nothing has already shifted. If you stop the tape at that early, blazing state, you haven't found nothing at all. You've found a universe that's smaller, hotter, denser, and simpler in pattern, but still absolutely packed with energy and structure. Even if you push your mental tape to the very edge where the math stops making sense, you're still dealing with some kind of something, a state of space-time and fields that may be radically different from what you're used to, but not the kind of absolute absence that word nothing seems to promise. So the question you started with before you turned off the lights, did it all come from nothing, starts to sound like it has layers. You can rewind and never quite touch the kind of nothing a strict philosopher would talk about. You keep landing on a different kind of something, fewer kinds of particles, simpler configurations, more extreme conditions, but still a real physical state. To get to nothing in the toughest sense, you'd have to somehow peel away not just the galaxies and atoms, but the underlying space, the time they occupy, and even the laws that govern how they behave. For now, though, you stay with this image of the tape paused near the beginning, the universe crushed into a furious, bright fog, all potential futures packed into a tiny, dense, searing state. It's not nothing. It's a very special something. And the next step is to stop rewinding, to press play, and to pay close attention to what that starting frame really means, because the story people tell about the Big Bang is often far simpler and far wronger than the strange, subtle reality your half-sleeping mind is beginning to circle around. You're still there, lying in the dark, with that mental remote control in your hand. A moment ago, you were running the universe backward like a tape, watching galaxies rush together, feeling everything compress and heat up. Now you pause the scene right before things get too wild, and you notice something funny about the picture you've probably carried around in your head for years. Somewhere deep in your imagination, the Big Bang still feels like a massive firework, going off at one point in the blackness, flinging glittering galaxies outward into an empty, waiting void. A bomb in space. Loud, bright, dramatic, very Hollywood. It's such an easy picture to believe because that's how explosions behave in your everyday life. You've seen slow-motion videos of bombs, fireworks, pop balloons, even water balloons exploding in the summer heat. There's always a center, some middle point where things start, and then pieces race out into the space around them. If you're standing off to the side, you're the observer, watching stuff fly past you. It feels natural to recycle that mental template and paste it onto the entire universe. Of course, the Big Bang must have been like that, right? Something blew up somewhere, and here you are, billions of years later, sitting on one of the flying shards, also known as Earth. But when you let that picture run in slow motion, it starts to fray around the edges. If the Big Bang were a bomb in space, then where's the center now? You could, at least in theory, point toward it like, yeah, the middle is over there behind that cluster of galaxies 30 billion light years to the left. Astronomers have looked. They don't find a preferred center where everything is racing away from one special point. No matter where you stand in the universe, if you're attached to a galaxy and you measure how other galaxies move, they all look like they're rushing away from you. It's not personal. You're not that special. The same thing would be true for an observer in some galaxy trillions of kilometers away from you in a random direction. From their point of view, they're the center too. That's already weird. In a normal explosion, only one lucky person gets to stand at the center, whoever is right where the bomb went off, which, to be clear, you generally don't want to be. But in this cosmic expansion, all galaxies can act as centers at once, just by standing still and watching everyone else recede. The only way that makes sense is if you quietly swap out your old idea. Instead of stuff expanding into space, you picture space itself stretching, carrying galaxies along like dots on the surface of an inflating balloon. There isn't a bomb in a room. The room is what's swelling. So you bring that mental balloon into your dark bedroom. Imagine tiny ink dots scattered across its surface. No one dot sits at the center of the surface. The whole skin of the balloon is the universe in this analogy, and as you inflate it, Each dot sees every other dot moving away. There's no need for an outside point where the bang happened, because the expansion is of the whole surface itself. Now take that two-dimensional balloon and mentally upgrade it to 3 dimensions, because your universe is not a flat rubber toy. It's a 3-dimensional space that can expand everywhere at once. Suddenly, the idea of a bang at a point in space starts to look like a kiddie drawing, charming but wrong. You remember that earlier moment when you were rewinding the cosmic tape and watching everything pile together. In that mental movie, galaxies didn't fly back towards some specific spot next to Orion or behind Andromeda. They all approached each other, everywhere, all at once. The density increased everywhere. The temperature rose everywhere. The visible universe, the part you can in principle see, shrank in scale, but never contracted into a tiny, sitting inside some huge, empty background. The whole stage itself was shrinking. The show didn't happen on a pre-built stage. The stage was part of the show. That also fixes another common myth, the idea that the Big Bang was like a bomb going off at a particular time, and before that time, there was just black nothingness stretching in all directions. The picture is usually long, boring era of infinite empty black, nothing happening, and then suddenly, kaboom, fireball in the middle. But if space itself is what's expanding, then before the expansion isn't just a giant, unused stage waiting for actors. That before might not have any meaning at all in the way your brain wants it to. Time itself is wrapped up in this, like threads woven into the fabric of space. When cosmologists talk about the Big Bang, they're not talking about a bomb igniting inside time. They're talking about the earliest frame of the film, the frame where time and space, as your physics currently understands them, first come sharply into focus. You let that sink in as you listen to the low hum of your room. There's something unexpectedly elegant about a universe that doesn't explode into pre-existing emptiness, but instead stretches itself into being. The fireworks picture feels flashy but shallow. This new one is quieter and stranger. Everywhere was once hotter, denser, more tightly packed. There was no outside, no border, no edge you could cross if you just flew your spaceship far enough and fast enough. Any direction you point eventually loops back into more universe, or into regions so far away that their light hasn't had time to reach you yet. And speaking of light, your mental camera zooms to another big clue that the cartoon version gets wrong: the leftover glow. If the Big Bang were just a single fireball in space, you'd expect its light to thin out, bounce off things, dim into obscurity, like smoke from an old fireworks show dissipating into the night air. What we actually see is a nearly perfect, uniform bath of microwave radiation coming from every direction in the sky, with tiny ripples of temperature sprinkled across it. This isn't the afterimage of a local explosion. It's the cooled-down echo of a time when the entire universe was a hot, glowing plasma, like the inside of a star, but everywhere. You can imagine yourself floating in that ancient light. There's no over there where it started. You're soaking in a relic of a time when space was so crowded with particles and light that nothing like a stable atom could exist yet. As the universe expanded and cooled, that plasma thinned, atoms formed, and the light streamed freely for the first time, filling space. It has been stretching with the universe ever since, its wavelength lengthening, its energy dropping, turning from blinding white-hot glare into gentle microwaves that your eyes can't see, but your radio antennas can. This isn't debris from a cosmic bomb. It's the fossil glow of a whole universe cooling. When you hold that picture in your mind, the words Big Bang start to feel a bit like false advertising. They conjure noise and chaos and shrapnel, when what actually happened was more like a relentless, smooth unfurling of space itself from a very compact, very energetic state. There wasn't a bang in the sense of an explosion with sound waves. There wasn't even air to carry sound. The name stuck because humans love dramatic branding, and once a catchy label lodges itself in textbooks and documentaries, it becomes almost impossible to dislodge. But underneath the name is a mathematical story of expansion, cooling, structure forming, not a cosmic grenade. You might notice another subtle shift in your thinking. In the bomb picture, you can't help but ask what exploded and where it was sitting. Those questions feel obvious and natural. What blew up? Where was it? In the expansion picture, those questions twist a little. What expanded was space-time itself, along with all the energy and matter within it. Where did this happen? Everywhere. Asking where within space the Big Bang occurred is like asking on which spot aligned the number line begins. The whole thing is the beginning. There is no left of zero in a number analogy, just as there may be no meaningful before in the time analogy. Your brain doesn't like that at first. It keeps reaching for a location, a center, a quiet corner where the fuse could be lit. You're gently telling it no. This is bigger and stranger than that. Of course, you can still have fun with metaphors. The raisin bread analogy, the balloon, the inflating grid, they're all your mind's way of grappling with something that doesn't fit neatly into day-to-day intuition. But you start to notice the limits of those metaphors. The balloon has an outside, but the universe, as far as you can tell, might not. The bread is rising in someone's oven, but the cosmos doesn't expand into some larger room. It's not rising inside a cosmic baking pan. These analogies are like floaties helping you swim in deep water. They keep you from drowning in abstraction, but you know better than to mistake them for the ocean itself. You think back to that early hot, dense phase you rewound to. At very early times, the densities and temperatures your equations point to are so extreme that the physics you use starts to wobble. General relativity and quantum mechanics, those two big pillars of modern physics, start shouting over each other like two experts who both think they're in charge. Extrapolating all the way back to an infinite density singularity might not even be physically real. It might just be what happens when your math insists on giving answers in a region where it's no longer qualified to speak. So, even the idea that there was a literal point where everything was infinitely compressed may be another myth you've quietly inherited. Instead, you let the phrase, very early universe, carry a gentle fuzziness. It was extremely hot, extremely dense, expanding extremely fast. That part is supported by the data, the cosmic microwave background, the distribution of galaxies, the success of nucleosynthesis calculations that tell you how much helium and hydrogen formed in those first few minutes. Those pieces line up like evidence in a detective story, all pointing to a fiery, compact beginning. But the exact moment zero, the true first tick of the cosmic clock, that might require a new, deeper theory, some marriage of gravity and quantum rules that you don't quite have yet. In the meantime, you can at least stop imagining a bomb going off in an empty warehouse. Your gaze, even in the dark, feels a little wider now. The bed under you is drifting through this expanding fabric. The atoms in your body cooled leftovers from that early inferno. The iron in your blood was forged later in stars and supernovae, sure, but the raw material, the protons and neutrons, were born in that hot cosmic cauldron. You're not sitting on a distant rock watching the explosion from afar. You're embedded in the aftermath, made of it, carrying the echo of that expansion in every particle. The bang isn't something you're safely observing from the outside. You are part of the bang that kept going, slowed down, cooled off, and eventually learned how to wonder about itself. And quietly, without you even trying, the old cartoon version starts to loosen its grip. The fireworks fade. In their place, you hold a calmer picture. A universe with no center, no explosive shrapnel flying into emptiness, just a vast, expanding fabric, once hotter and denser, now cooler and structured, filled with galaxies that all see one another rushing away. It's less cinematic in a cheap special effects way, but somehow far grander. The whole thing didn't just blow up. It began, it stretched, it cooled, and it's still unfolding around you right now, even while you lie there listening to the quiet. You let that calmer picture of the Big Bang hover in your mind for a moment. Not an explosion, but a hot, dense, smooth beginning that expanded and cooled. Smooth is a tempting word here. It makes you imagine a perfectly even universe, the same everywhere, like a flawless fog of particles and light. But if it had stayed perfectly smooth, you wouldn't be here in bed right now. No stars, no galaxies, no planets, no heavy elements, no chemistry, no brains, no weird late-night questions about nothing. To get all the structure you see around you, you needed wrinkles, little imperfections, tiny differences between one spot in the early universe and another. So now you turn your attention to those wrinkles, those first ripples. If you could rewind the universe again, past the formation of atoms, past the glowing plasma, closer and closer to that early inferno, you'd reach a time when space was packed with fields and particles in a state you'd probably describe as chaos. Yet hidden in that chaos were tiny variations, places that were just a tiny bit denser, a tiny bit hotter, a tiny bit different from their neighbors. The shock is how tiny those differences were. Imagine a flat, calm ocean disturbed by ripples only a millimeter high spread across thousands of kilometers. That's the scale of the unevenness you're dealing with. Where did those tiny ripples come from? Your mind reaches back to something you already touched on, the vacuum that refused to be truly empty. Quantum fields filling space, jittering even in their lowest energy state. Those fluctuations aren't just theoretical scribbles in a textbook. They're built into the way reality behaves when things get small and energetic enough. If you zoom in far enough, the calm surface of nothing turns into a storm of possibilities popping in and out of existence, like waves on the surface of a restless sea. Here's where the story gets especially wild. In our normal, everyday universe, those quantum jitters stay microscopic. They're confined to tiny scales, constantly appearing and disappearing, averaging out so that at large distances, everything looks smooth and predictable. But in the very early universe, conditions were not normal. Space itself was expanding at a breathtaking rate, especially if something like cosmic inflation happened, a period when the expansion sped up dramatically, stretching distances so quickly that tiny quantum ripples got yanked from microscopic scales up to cosmic ones. You can think of it like this. Take a tiny ripple in a rubber sheet, almost too small to notice. Now start stretching the sheet at an insane speed. The ripple stretches too. It gets longer, taller, more visible. Something that started as a jitter in a microscopic grain of the sheet becomes a big, gentle bump you can see from far away. In the early universe, quantum fluctuations in the fields filling space got stretched out like that. What would have been random little jittery blips became large-scale variations in density across the cosmos. You don't need to picture the precise math. You can just hold the idea that the universe took its own quantum noise and turned it into its large-scale pattern. Places that were slightly more packed with energy and matter became the seeds of future structure. As the universe expanded and cooled, gravity got to work on those tiny differences, pulling a bit more strongly where there was already a touch more stuff. Dense regions grew denser. Sparse regions got emptier. Over millions and billions of years, those initial ripples grew into the cosmic web. Filaments of galaxies and clusters, vast voids where almost nothing lives, grand structures that span hundreds of millions of light years. The first real snapshot you have of those ancient ripples is that microwave background you imagined earlier, the fossil light from when the universe was about 380,000 years old. When scientists map it carefully, they don't just see a uniform glow. They see a modeled pattern, tiny temperature differences spread across the sky, only a few parts in 100,000. Those temperature spots are essentially a photograph of the first wrinkles, a baby picture of the universe's ripples before they grew up into galaxies. And buried in that baby picture is the signature of quantum fluctuations. The statistics of those patterns, the way the hot and cold spots are arranged, match what you'd expect if tiny quantum jitters were stretched by cosmic expansion and then frozen into place as density differences. It's as if the universe took a screenshot of its own quantum chaos and printed it onto the sky. When you look at those maps, you're staring at the fingerprint of the vacuum itself. You let that sink in while your body settles deeper into the mattress. The bed under you, the walls around you, the entire Earth, the sun, the Milky Way, all of them trace their existence back to those tiny primal ripples. The cloud of gas that collapsed to form your star was once just a slightly denser patch in a much larger gas field, and that slight edge came from fluctuations that, long before, were quantum jitters in a field when the universe was unimaginably young. You're not just made of stardust. You're shaped by quantum noise, by the ultimate background buzz of reality. There's a kind of quiet comedy in that. All your careful plans, your to-do lists, your hopes, your anxieties, all of them unfold inside a structure whose blueprint started as tiny random jitters magnified by cosmic expansion. That doesn't make your choices meaningless. It just means the stage you're acting on was laid out by a process that begins in something as slippery and probabilistic as quantum mechanics. The layout of the cosmic web, the fact that there's a galaxy here and a void there, that there's a long chain of cause and effect that led to a planet in a habitable zone and a species that built microphones and mattresses and streaming platforms. That whole chain traces back to the universe, amplifying its own microscopic fuzz. You wander mentally over one of those early dense patches. At first, it's just a slightly higher density in a soup of particles. As time goes on, that patch's gravity tugs more material in. It forms a cloud. Irregularities inside the cloud grow into smaller clumps. Those clumps spin and flatten into disks, eventually igniting as stars in their cores. Some stars are massive and live short, dramatic lives, ending in explosions that seed heavier elements into space. Those heavier elements find their way into new clouds, new stars, and the disks around them. In one of those disks, far down the line, the debris pulls together into rocky worlds and gas giants and icy leftovers. On one of those rocky worlds, chemistry experiments itself into biology. Biology evolves into brains. Brains form thoughts. And here you are, tracking the chain backward, lying still and aware, following a trail that starts with almost nothing, just slightly lumpy quantum noise in a very young universe. It would be easy to treat quantum fluctuations as some cold, abstract concept, a footnote in a physics lecture. But they're not just numbers on a page. They're part of the story of how you got a sky to look at, a tree to sit under, a city to walk through, a soft pillow under your head. Without those tiny, uneven patches, gravity would have nothing to amplify. The universe might still be a diffuse fog of particles, too smooth ever to clump, too featureless ever to write a story on. You might also notice that this whole story quietly bends your sense of scale. Quantum mechanics usually feels tiny. You think of atoms, electrons, little subatomic pieces flickering around. Cosmology feels enormous. Galaxies, clusters, horizons billions of light years away. Here, the two domains shake hands. The tiny and the huge are not separate stories. They're different chapters of the same one. The smallest fluctuations in the fabric of reality got promoted to the architects of everything large. So when you say quantum and when you say cosmic, you're really just looking at the same system through two different zoom levels. There's another twist hiding in the background. Quantum fluctuations are random, but not random in the roll a chaotic die, way your everyday brain imagines. They're governed by precise probability rules, patterns that show up statistically when you look at many of them. The ripples seeded by them carry that same delicate balance. They're not a chaotic mess, but they're not a rigid crystal either. They're structured enough to measure, but not so structured that you could have predicted the exact positions of every galaxy before the universe began. That balance between law and chance, rule and randomness, is part of why the cosmos looks the way it does. Messy yet patterned, wild yet strangely orderly. You sit with that for a moment. The night around you is quiet, but behind that quiet is a universe that never really knew what perfectly smooth mint. From its earliest moments, it was vibrating, jittering, peppered with little differences that would become everything. Even in its most uniform phase, it was already rehearsing the future. Every ripple in that primordial light was a promise. Here, someday, stars will ignite. Here, someday, planets will spin. Here, someday, maybe someone will look up, squint at the sky, and ask where it all came from. And then there's the simplest, strangest part. The same principles that tell you no vacuum can be completely still also tell you that the early universe couldn't help but carry those fluctuations. Nothing special had to be added. You didn't need someone to tap the universe like a drum to get the first ripples going. Given a quantum field and a rapidly expanding space-time, those ripples are just what happens. The cosmos wrote its first draft of structure using the built-in restlessness of nothing. You lie there, feeling the softness of your bed, the weight of the blanket, the gentle stir of air in your room, and somewhere in that stillness you can almost picture those first cosmic ripples, stretched across unimaginable distances. They're long gone now, transformed into galaxies and clusters and the vast scaffolding of the universe. But their ghost is still visible in that background glow. It's like looking at wrinkles in an old photograph and realizing those wrinkles dictated the shape of your entire life. The question that started this whole journey, did it all come from nothing, isn't answered yet, but it's already shifted. Nothing now includes jittering fields, restless vacuums, and quantum ripples that become everything. The word has been quietly smuggling in more structure than you first realized. And the more you see how much can grow out of such tiny, ghostly beginnings, the more you suspect that any simple picture of nothingness was never going to survive contact with the real universe. By now, your idea of nothing has been stretched pretty far, but the question you keep circling back to is awkwardly simple. Can a universe like this really just show up? Somewhere deep in your brain, there is a stubborn voice from a high school science class saying, energy cannot be created or destroyed. That voice sounds very sure of itself. If energy can't just pop into existence, how did you get galaxies, stars, planets, and you? You feel like a kid who went to sleep with an empty piggy bank and woke up to find it stuffed with cash, and all the adults just shrug and say, yeah, that's how piggy banks work, don't worry about it. So you go back to basics, right here in bed. You picture that piggy bank, or better yet, a simple bank account. If you deposit $100, your balance goes up by 100. If you take out 50, it goes down by 50. The total is always being tracked. That's how the law of conservation of energy feels. Like a cosmic bookkeeping rule that says you don't get something for nothing. Every gain has a cost. Every appearance has a source. But then you remember something strange from earlier. The vacuum isn't actually nothing. It's full of jittering fields that can produce little particle and antiparticle pairs, as long as they disappear quickly enough that the books stay balanced. Those tiny happenings never leave a lasting trace, at least not individually. They come and go too fast. Now, imagine trying to scale that kind of thing up. Could you ever get a whole universe as a kind of cosmic version of that? A big blip where the books still somehow add up? To even ask that question, you have to look more carefully at what energy means when gravity gets involved. In everyday life, you think of energy as something intuitive, the gasoline in a car, the food in your body, the electricity in a wire. These all feel like positive quantities, stuff you burn or use up. Gravity complicates this picture in a sneaky way, because gravitational energy comes with a minus sign. You imagine holding a book at arm's length above the floor. It has gravitational potential energy because you could drop it and let it convert that stored energy into motion and sound, and maybe a small dent in the wooden boards. The higher you hold it, the more energy it has. Now imagine slowly lowering the book to the floor without dropping it, letting it gently slide through your fingers as your muscles relax. Where did that potential energy go? In a sense, it's been released. You did a bit of work with your muscles, and the book is now in a lower energy configuration. On a cosmic scale, gravity is always trying to pull things together into lower energy states. Two masses far apart have more gravitational potential energy than the same masses close together. When they fall toward each other, the decrease in potential energy can show up as heat, light, motion. But if you try to assign a number to the gravitational energy itself, it comes out negative compared to a situation where nothing is there at all. It's like a debt on the cosmic bank statement. Now you picture the universe as a huge, complicated financial spreadsheet. On one side of the ledger, you have positive contributions, the mass energy of particles, the light streaming through space, the energy stored in fields. On the other side, you have negative contributions from gravitational attraction, the energy tied up in the fact that all this stuff can fall together. If those positive and negative entries are carefully balanced, the grand total could, in principle, be zero. A universe full of stuff might still add up, overall, to nothing. This is the heart of one of the more mind-bending ideas you're drifting through. That you don't necessarily have to violate conservation of energy to get a universe from nothing, as long as that nothing includes the possibility of positive and negative pieces that sum to zero. It's like someone handing you a wallet filled with $100 in cash and a note saying you also owe exactly $100 in debt. You have money, you can buy things, but your net worth is still zero. From the right accounting angle, nothing has changed. Of course, the universe's bookkeeping isn't literally done in a spreadsheet. Once gravity and curved space-time enter the game, the very notion of total energy becomes slippery. In your day-to-day life, you're used to adding up energies in simple systems with clear boundaries. A ball rolling on a table, a car driving up a hill. But the universe doesn't have an obvious outside. It doesn't sit inside a larger space you could stand in and say, okay, let me total all the energy inside that box. The box is the universe. If space itself is the stage, there's no higher balcony to watch from. Still, even with all those caveats, cosmologists can write down models where something remarkable happens. If the universe starts in a very simple, almost featureless state, the interplay between positive matter energy and negative gravitational energy allows it to expand and structure itself without needing some external source to pay for it. You're back to that piggy bank, but this time the bank prints its own currency and its own debt in just the right amounts as it grows. From the inside, you see stars ignite, galaxies form, and everything feels like an enormous increase in stuff. From a carefully chosen, abstract vantage point, the total might still be very close to zero. You let your mind float over a much smaller analogy. Imagine you and a friend ice skating on a frozen lake. You're both at rest, holding hands. Then you push off and start gliding in opposite directions. Suddenly, there's kinetic energy in the system. You're both moving. Did that energy come from nowhere? No. You did work with your muscles, and the total momentum of the system stayed balanced. Your momentum in one direction is canceled by your friends in the other. The center of mass still sits in the same place. The motion looks like something came out of stillness, but the rules were quietly respected the whole time. Now scale that up in a way your brain doesn't love but can kind of squint at. If space-time can curve and stretch, if fields can store energy and gravity can take some away, you might get a situation where the universe blossoms from a very simple state without breaking any fundamental rules. The universe doesn't steal energy from somewhere else. It rearranges the way energy and gravity interact so that richness blossoms out of a balance sheet that still totals to zero. This doesn't mean you now have a complete answer. You haven't solved the mystery of why there is something rather than nothing. You've just made the question more precise. Now the puzzle sounds more like, why is there a state of reality that allows for a zero total energy universe with quantum fields and gravity and all the rules needed for these games to play out? It's like you opened what you thought was the last door in a hallway and found another corridor behind it, stretching off into the dark. You answered one version of how, but the deeper why slid out of reach and settled just a little further away. Still, this zero-energy idea does something important for your restless mind. It shows that your gut-level rule, no free lunch, no something from nothing, doesn't work quite the way you thought when gravity and quantum fields are involved. The universe may not be a blatant cheater. It might be more like a clever accountant, constantly pairing every positive term with a negative partner so that the overall rules stay intact while complexity flourishes. You think back to those quantum fluctuations that got stretched into cosmic ripples. In the picture you're holding, those fluctuations didn't need an extra kick from outside reality. They were part of the fabric of the vacuum itself. If the early universe could ride on that structure, if the expansion could convert those tiny jitters into large-scale patterns, then you have a chain of events where the universe builds its own structure from its own internal noise and balances the books through gravity. There's a quiet comfort in that. It means the universe, for all its apparent extravagance, might be very modest at heart. You don't live in a world that overspent some unimaginable budget. You live in a reality that might be, on the grandest scale, exactly as expensive as nothing. The fact that you get sunsets and whales and exoplanets and jazz and the smell of coffee in the morning is like the interest you earn on a perfectly balanced account, not a sign that someone robbed a cosmic bank. Of course, if you look at your life from inside it, it doesn't feel like nothing. Pain doesn't feel like nothing. Joy doesn't feel like nothing. The weight of your body on a mattress, the memories that flicker through your mind, the quiet ache of things you wish had gone differently, the soft gratitude for things that went better than you expected. None of that feels like a zero. You're allowed to hold both pictures at once. On the one hand, a universe whose grand total might be nothing more than a neat mathematical zero. On the other hand, a universe whose details matter deeply to the small, temporary beings who get to look around and care. As you breathe in and out, you can imagine two ledgers open side by side. One is the cosmic one, full of abstract terms for fields and geometry and energy densities, with some theoretical cosmologist carefully adding and subtracting until they get that suspiciously tidy zero. The other is your personal one, filled with first days of school and awkward conversations and inside jokes and nights when you couldn't sleep. Both ledgers are real in their own way. One doesn't erase the other. If anything, the cosmic neatness makes the messy richness of your lived experience even stranger. And under both ledgers lurks that nagging word again, nothing. You've already seen how slippery it is. For physicists, nothing might be a special state of a field. For a philosopher, it might be the complete absence of being. For you, lying here in the dark, it might be just the pause between thoughts, the moment when you stare at the ceiling and your mind feels blank for half a breath. Each of those senses pulls you toward a different picture of where the universe comes from. Tonight, you're letting one particular picture glow softly in your mind. A universe that could, in principle, be its own explanation in terms of energy, a vast structure whose total cost rounds to zero when you look at it through the right lens. It doesn't settle the ultimate question, but it shows you that something from nothing isn't as obviously forbidden as your gut wants it to be. The rules of the game are more flexible, more subtle than the simple slogans you grew up with. You don't need to nail down every detail to feel the weight of that idea. It's enough for now to know that there are ways the universe can be both lavishly full and, at the same time, kind of free in the deepest accounting sense. A cosmos that owes nothing to anything outside itself, that generates structure not by breaking rules, but by playing them to the limit. You roll onto your side, maybe tug the blanket a little closer, and let that strange, delicate balance hang there. A universe full of light and matter, grounded in laws that might allow the total tally to be nothing at all. The more you turn it over in your mind, the more you feel the need to sharpen the word nothing itself, to separate the nothing of empty space from a deeper, more radical emptiness that might not even have laws or fields. That question, you realize, is where your thoughts are heading next. The question that's been quietly forming in the back of your mind is simple, but slippery. When you say nothing, which nothing do you mean? You've just spent all this time realizing that the vacuum of space is not really empty, that it has energy and fields and jittery quantum behavior. So if that's not nothing, then what is? Are there different kinds of nothing, stacked like layers, each one stripping away more and more of what you thought could be removed? Lying here, you almost picture yourself peeling an onion of existence, hoping there's a perfect blank in the center, and half suspecting there might not be. You start with the easiest kind, the one your brain has used since you were a child. Everyday nothing. An empty room, an abandoned parking lot at night, a blank page, a phone battery at 0%. These are all things you've probably called nothing at some point, but you know they're not truly empty. The room has air, dust, background radiation, the faint smell of whatever was there last week. The parking lot is asphalt, insects, tiny bits of trash tumbling in the wind. Even the blank page already carries rules, lines or margins, or the invisible expectations of grammar and handwriting. And a dead phone still has atoms, circuits, stored charge differences waiting to be rearranged. This everyday nothing is more like no obvious stuff. No furniture, no people, no text. But underneath, there's still a lot going on. Molecules vibrating, gravity tugging, light waves passing through. You realize this basic sense of nothing is really just your brain being lazy and zoomed out. You aren't noticing the details, so you call it nothing. It's like squinting at a star and seeing a simple point of light, ignoring the whole furnace buried inside. Then you slide your attention outward, past the walls of the room, out beyond the planet, into the dark between the stars. This is where your intuition used to think real nothing finally started. No walls, no air, no clutter. Just blackness and silence. But now you know even that isn't truly empty. We still have the quantum vacuum humming away, fields everywhere, constantly fluctuating even in the coldest, loneliest stretches of space. If you remove all the atoms, all the light, all the obvious matter and radiation, the fields remain. Space itself remains. The canvas doesn't disappear just because you've scraped off the paint. So maybe the next level of nothing is this space with no stuff in it, but with the laws of physics intact. A bare stage, no actors, no props, but the lighting rig is in place, the sound system is wired, and the script is tucked backstage. In that kind of nothing, you still have distances and directions. You still have time ticking. You still have equations that say what would happen if something were there. It's a kind of emptiness that feels more respectable, more worthy of the word. Yet it's still a something. It's a structure. It has geometry and rules and possibilities. Lying in the dark, you realize how important that word possibilities is. Even if nothing currently occupies a region of space, the fact that something could exist there in principle means you're not at the deepest level of nothing. It's like a parking lot at 3 in the morning. No cars right now, but the painted lines and the payment machine and the residents' only sign all silently assume that cars are real and could show up at any minute. The emptiness is contingent. It's waiting for occupancy. If you want a more severe kind of nothing, you have to do something ruthless in your imagination. Take away the space itself. Now you're trying to picture no vacuum, no arena, no place where anything could be. The distances you use to measure things with are gone. There is no over there to point to, no later to wait for. When you try to visualize this, your brain immediately cheats. It gives you an empty black box, or a gray fog, or a blank white canvas stretching to nowhere. That's not nothing. That's still a kind of something. It's space wearing a costume that says void. You catch yourself doing it and gently correct the picture. No box, no fog, no backdrop at all. Not even darkness, because darkness is still a visual impression of something not being lit. You're trying to talk about the absence of a place where light and dark could even exist. At this point, words start to feel like they're dissolving in your hands. You're not just stripping away stuff, you're stripping away the container that stuff would live in. And yet even that severe emptiness still might carry something subtle. Rules. Maybe there's no space, no time, no fields, but there are underlying laws or equations that say what could happen if space and time ever did appear. In your mind, you can compare it to software code sitting and used on a hard drive. The program is there as a pattern, as a possibility, even if it's never run. Is that still a kind of something? Probably. If there are rules written anywhere, even in some abstract sense, you haven't reached a truly absolute nothing. So you push further. Imagine taking away the laws themselves. No equations, no constants, no background logic saying if this, then that. Now you're not just erasing the universe. You're erasing the instructions for how universes could exist at all. At this stage, you're well past anything physics normally talks about. Physics, by its nature, assumes there are patterns to discover, rules to write down. A reality with no rules at all is almost indistinguishable from no reality. Your thoughts slow for a moment as you notice how radical that is. The deeper you go into nothing, the less physics you can actually do. Scientists are very good at describing structured states, even very simple ones like a uniform vacuum with certain properties. But once you start removing structure itself, you step into territory where the usual tools don't work. It's like trying to describe a book when there are no letters, no language, and no storyteller. At some point, the question stops being what happens and becomes, does it even make sense to talk about something here? This is where philosophy and physics start to blur together, whether they like it or not. You can have a mathematically neat state in a theory, a lowest energy configuration of some quantum field, for example, and call that nothing inside the theory. But that nothing still sits within a framework of assumptions. What fields exist, what symmetries they have, what the menu of possible states looks like. When a physicist says the universe could have emerged from nothing, they often mean from a state with no particles in a particular theory that still has fields and laws. From the viewpoint of philosophy, that's more like a very minimal kind of something, not a literal absence of being. Stretching out on your pillow, you let those two perspectives sit side by side. One is practical. Define nothing as the simplest allowed state in a model. Then ask if you can get more complicated states, like expanding universes, out of that using the rules of the model. That's how you end up with ideas about quantum fluctuations, maybe spawning universes, or space-time tunneling from one configuration to another. The other perspective is more absolute and more unforgiving. It says, if there is any structure at all, laws, possibilities, logical truths, then that's not real nothing. You can feel how easy it is to talk past yourself if you don't keep those senses separate. When you hear a headline claim that the universe came from nothing, your mind might imagine the harshest, deepest version. No space, no time, no laws, no logic. But the math in the paper might be talking about something gentler. A particular vacuum state in a quantum gravity theory. A featureless but still well-defined configuration from which other configurations can emerge. It's not that anyone is lying. It's that the word nothing is being stretched in different directions. To calm your thoughts, you start at the top again and walk down the ladder, but more quickly this time. First, the everyday nothing of empty rooms and blank screens. The kind that evaporates the moment you think about molecules and air and dust. Then the cosmic vacuum, empty of particles but rich in fields and geometry. Then the more radical idea of no space and no time, where you can't even define a distance or a duration. Then the still harsher idea of no laws, no rules, no underlying equations. By the time you reach that bottom rung, the word nothing has changed from a casual shrug into a kind of philosophical cliff. You notice something else along the way. At each step down, it gets harder to say what it would even mean for a universe to come from that level of nothing. If you have a vacuum with laws, you can imagine quantum fluctuations and tunneling events and all the mathematical machinery that might produce a big bang, like beginning. If you remove space and time, but keep some deeper set of rules, you can still imagine a kind of pre-geometric reality where space-time emerges as a feature, the way temperature emerges from atoms. But once you take away the rules themselves, you're left with a question that doesn't know how to cash itself out. How could something arise from literally no structure at all? Might be like asking, what is north of the North Pole? The words fit together, but the situation they describe doesn't exist. This realization doesn't make the mystery smaller, it just gives it sharper edges. You see that when different people talk about whether the Big Bang came from nothing, they might be aiming at different depths of that ladder. Some are content to say, nothing is the simplest allowed state in our equations, and here's how something richer can emerge from it. Others are hungry for an ultimate explanation that starts from the most radical emptiness imaginable, and they are rarely satisfied with anything that sounds like a preloaded framework. You, lying here and letting your thoughts wash back and forth, don't have to pick a camp tonight. You can appreciate the power of the physics answer. How far we can go by tracing the story from a hot, dense, early universe, back into quantum behavior, and possibly into some minimal starting state. And you can also feel the pull of the philosophical answer that keeps whispering, but why is there any framework at all? Why these rules and not none? In a way, the ladder of nothings has become a ladder of questions. At the top, you ask simple things like, what was before the Big Bang? And where did all the matter come from? Deeper down, you ask, why is there a vacuum with these properties? Then, why are there any laws? And at the very bottom, you hit something like, why is there anything that could be described as real instead of absolutely nothing? That last question doesn't sit comfortably in equations. It sits in your chest, in the quiet space between breaths, as a kind of ache. You might never get a final, definitive answer. But there is a strange peace in understanding that the word nothing is not a single, clear rung on the ladder. It's a whole staircase of thinning structures, each one more ghostly than the last. The Big Bang story, with all its math and measurements, operates on some of those rungs very well. It can explain how things evolve once there's a vacuum, once there are fields, once there is space-time. On the lowest rungs, language starts to crumble, and you're left with wonder more than explanation. You shift your head on the pillow, maybe feeling the fabric cool against your skin, and let that layered picture settle. The universe might not have sprung from the harshest, most absolute version of nothing you can imagine. When cosmologists talk about nothing, they might mean a strangely structured, kind of almost nothing that still has rules and potential. Whether that satisfies you or not, you now see that the question, did the Big Bang come from nothing, is far richer and more tangled than it looked at first glance. And as your mind grows used to this tangle, another curiosity rises up, quieter but persistent. If the vacuum really has hidden structure, if space itself carries energy and fields even in its emptiest state, can we actually see that in action? Does this supposedly empty, almost nothing, ever leave fingerprints we can measure? That thought turns your attention gently toward the experiments, the clever human tricks where we try to make nothing do something just to prove to ourselves that it's not as empty as it pretends to be. You've just climbed down that ladder of nothings, and right before your thoughts got completely tangled, you asked a quiet question. If the vacuum is secretly structured, can we actually catch it in the act? Does this almost nothing ever show its hand in a way you can measure, not just imagine? That's where your mind goes now, still lying in the dark, but drifting into laboratories full of metal, glass, and very human stubbornness. People who were so annoyed by the idea of nothing that they decided to poke it with very expensive equipment. You picture a lab bench, maybe a little messy, cables spilling over the edges, a coffee cup that should not be that close to the instruments, a vacuum chamber sitting in the center like a metal pumpkin. Scientists pump out the air until the pressure inside is a tiny fraction of what's outside. They remove the gas, the dust, the stray molecules, all the obvious clutter. If the old intuition about nothing were right, that chamber should be boring. With all the stuff gone, there should be nothing left to do, nothing left to measure. But there is a famous experiment that says otherwise, and it begins with something almost childishly simple: 2 metal plates. In your mind, you watch those plates being polished, flattened, and then lined up face to face very, very close together. Closer than a grain of dust, closer than a human hair, separated by just a tiny gap. The air between them is pumped away. No gas, no plasma, no visible anything. And yet, when the plates are released and allowed to move freely, they drift toward each other, as if pulled by an invisible force. That gentle tug is called the Casimir effect, named after the physicist who predicted it, and it's one of the clearest hints that the vacuum isn't just a blank, passive stage. It acts more like a restless medium, crowded with possible vibrations. You let the explanation waft slowly into your mind. In quantum field theory, even empty space is full of modes, like all the different ways a musical instrument could vibrate if you plucked it. Most of the time, those possible vibrations cancel out, giving you a quiet average. But when you put two metal plates very close together, you limit which wavelengths of vacuum ripples can exist between them. Some modes don't fit. Outside the plates, all the modes are allowed. Inside, only certain ones are. The result is a tiny difference in vacuum energy between the inside and the outside, and that imbalance pushes the plates together. In other words, your tiny metal sandwiches feel a force because the quantum vacuum is not the same everywhere. What's important, as you let this sink in, is that this isn't just a funky metaphor. People have actually measured that force. They've changed the distance between plates, varied the materials, refined the setups. The numbers match what the math predicts. You can't see little particles popping in and out like cartoon sparks, but you can feel the result of treating empty space as a sea of allowed and disallowed vibrations. It's like realizing that even when a room is silent, the air still has a pressure you can measure if you lean on the wall. You drift from a lab with the plates to another quiet scene, this time a beamline in a physics building where atoms are coaxed into radiating faint light. Decades ago, when physicists measured the light coming from excited hydrogen atoms, they noticed something odd. The energy levels weren't exactly where their neat equations said they should be. There was a tiny shift, small but real. That mismatch became known as the Lamb shift, another little bruise left on reality by the fact that the vacuum isn't clean and empty. Here, your imagination zooms in on a lonely electron bound to a proton, making up a hydrogen atom. In a perfect classical universe, its orbit would be crisp and sharp, its energy levels exact. But in the quantum universe you actually live in, the electron is constantly being jostled by the vacuum fields around it. Those quantum fluctuations slightly alter the environment the electron feels, nudging its energy up or down by a minuscule amount. The result is that the spectral lines, the colors of light the atom emits, are shifted just enough that meticulous human beings with lasers and patience can notice. That's the Lamb shift in a bedtime-sized nutshell, the vacuum modifying the fine details of an atom's behavior. Once again, if the vacuum were truly nothing, no fields, no fluctuations, those shifts wouldn't be there. The fact that they are, and that they match precise calculations, is another quiet signature. Empty space, it seems, insists on having an opinion about how electrons behave. You let your focus broaden a little from single atoms to the more general idea of vacuum polarization. This is where the vacuum behaves like a weird kind of material that can respond to electric fields. Around a charged particle, the quantum vacuum can briefly act as though particle and antiparticle pairs exist for a flickering moment, slightly screening or smearing out the original charge. Again, no one is watching little pairs appear and vanish like fireflies. Instead, you see the effect in how forces behave at different distances and energies. High-energy experiments, smashing particles together in colliders, reveal that the electric charge of particles seems to run or change with energy in a way that only makes sense if the vacuum itself is allowed to get involved. All of this paints an odd picture. You started with nothing as no stuff, and now you're dealing with nothing as a medium that shifts atomic energy levels, pushes metal plates together and refracts electric fields like some invisible glass. It's almost rude of the vacuum, really. You tried so hard to simplify it and just kept insisting that it has structure. Your thoughts skip to something even stranger, making light from nothing. There's an effect called the dynamical Casimir effect, where if you move a mirror very rapidly, faster than your intuitive sense of, oh, that's just back and forth, you can actually pull real photons out of the vacuum. The moving boundary conditions disturb the quantum fields enough that what was previously just virtual, a kind of mathematical whisper in the equations, turns into actual, measurable light. In practice, people use clever substitutes for literally shaking mirrors at near-relativistic speeds, but the core idea is the same. Change the geometry of your empty region fast enough, and emptiness will radiate. This is where the line between virtual and real feels especially fuzzy in your sleepy mind. On paper, so-called virtual particles are bookkeeping devices inside calculations, not tiny bullets with definite lives. But the fact that manipulating boundaries and fields in just the right way can coax measurable outcomes out of the vacuum is hard to ignore. Whatever language you use, the vacuum is not a passive backdrop. It can be stimulated, rearranged, and, in a sense, milked. You remember, too, that even an isolated atom sitting in a vacuum doesn't just sit forever in an excited state. It eventually emits light and drops to a lower energy. One way to say that is, the vacuum itself nudges the atom into radiating. If space were truly empty, with no fields to interact with, an excited atom might never spontaneously emit a photon. Cavity experiments, where atoms are placed inside specially structured spaces, actually show that you can speed up or slow down their decay by changing how the vacuum modes are allowed to exist around them. Again, the supposedly empty space is behaving more like a tunable instrument. Far away from those tidy optical benches, your imagination wanders back out into the cosmos. Near the edge of a black hole, theory predicts something eerie. Hawking radiation, where quantum effects in curved space-time should cause black holes to slowly leak energy, as if the vacuum itself were peeling off particles at the horizon. No one has yet watched a black hole evaporate in real time. The universe is too slow and we are too impatient, but the physics is strikingly similar. When you mix strong fields, curved space-time, and quantum fluctuations, the vacuum starts to act like a source. Not a roaring fountain, but a persistent dribble. You think about how all these examples, from Casimir plates to Lamb shifts to hypothetical Hawking glow, share a quiet theme. They don't show you the vacuum as a place where things appear from literally nothing in the cartoon, magical sense. Instead, they show you a structured quantum field that responds, shifts, and sometimes converts its hidden energy into more obvious forms given the right push. When cosmologists talk about early universe inflation or about quantum fluctuations seeding galaxies, they're building on that same notion. Space itself is a thing. Its emptiness is not really empty, and the experiments are like tiny windows, letting you peek in and see that restlessness indirectly. Lying there, you let a simple comparison float up. Imagine the ocean on a windless day. To a casual glance, it looks flat and calm, almost featureless. But if you had a sensitive enough instrument, you'd notice small ripples, subtle currents, the faint sway of the water. The vacuum of quantum fields is more like that ocean than like a perfectly rigid floor. Casimir plates are like narrow docks that shape the waves. The Lamb shift is like listening for tiny changes in sound when the water brushes against a hull. None of it makes sense if the sea isn't there. What's almost amusing is how much work humans had to do to prove that what they call nothing is actually something. You needed polished metal, high-grade pumps, ultra-stable lasers, and decades of careful theory to reveal that the thing you thought was emptiness is, in fact, the most universal medium of all. Space is everywhere, and everywhere it carries this quantum structure. You've never stepped outside of it, never floated in true, absolute nothingness. Every breath you've ever taken, every thought you've ever had, happened inside this restless, humming vacuum. As that realization settles, you can feel the original question about the Big Bang shifting a little. When people ask whether the universe came from nothing, the experiment suggests that the nothing in play might already be loaded, the way a clear sky is loaded with light you can't yet see. If a vacuum with quantum fields can shove plates together, tweak atom energies, and maybe sparkle at black hole horizons, it's not impossible to imagine that under extreme conditions, it could also blossom into a whole hot, dense universe. Still weird, still mysterious, but less like a rabbit from a hat and more like a dramatic phase change of a medium that was already there in some mathematical sense. You let your thoughts move slowly and smoothly from those tabletop experiments back to the early cosmos. The same language of modes and fluctuations and fields that explains Lamb shifts and Casimir forces also shows up in equations about the primordial plasma and the origins of the cosmic microwave background. The emptiness in your bedroom, the emptiness between galaxies, and the emptiness that might have existed before the first light all share that common structure. They are not perfect voids. They are stages with built-in rules for how drama can unfold. Somewhere in all this, another, more subtle puzzle begins to glow. If the vacuum has structure and the universe has dynamics, why does time itself seem to flow one way? Why are you lying here with memories of the past and not of the future? Why did the universe begin in such a low entropy, ordered state that everything since then has been a long slide toward disorder? If emptiness is so full of possibilities, why is the story written in one direction? The experiments with almost nothing have convinced you that the vacuum is real and active. Now your curiosity turns to the beginning and the direction of the whole narrative. You feel yourself leaning gently toward that next question, the one about time's arrow and how it might be tied to the strange, improbable orderliness of the universe's earliest moments, like a clock wound impossibly tied at the start. That question about direction has been quietly building in the background, like a soft pressure behind your eyes. You've accepted that the vacuum isn't really empty, that the early universe was hot and dense and wild, that quantum fields jitter even when nothing obvious is happening. But now you're stuck with a more intimate puzzle. If the underlying rules of the universe are so calm and reversible, why does your life feel like a one-way trip? Why can you remember last year, but not next year? Why do ice cubes melt, but never unmelt on the kitchen counter just because they feel like it? Your mind leans into that puzzle while you lie there, feeling the simple, reassuring flow of time in your body. Your stomach is digesting food and not the other way around. Your phone battery runs down and never spontaneously charges itself back up on a nightstand. Your room slowly gathers dust and clutter unless you intervene. No matter how many fancy words physicists invent, you keep bumping into this basic sense that the future and the past are different in a deeply physical way, not just because of your mood or your memory. And yet, if you could shrink down inside the equations that govern small things, the way electrons move around atoms, the way two billiard balls collide, the way a photon bounces off a mirror, you'd find something unsettling. Most of those equations don't actually care which direction in time you call forward. If you filmed certain microscopic processes and played the video backward, the math would shrug and say, sure, that's allowed. On the most basic level, the laws look almost ambidextrous, able to deal with time going either direction. That mismatch between reversible microscopic rules and your one-way everyday experience is where entropy sneaks in, like a quiet narrator explaining the twist in a movie. Entropy is a slippery word that people love to translate as disorder, but what it really measures is how many ways a system can be arranged while still looking basically the same from far away. You picture your bedroom right now. If you want it spotless, every book squared, every shirt folded, every item exactly where you chose, that's one special arrangement. But if you don't care where anything is, if clothes somewhere over there is good enough, there are an enormous number of possible messes. The crucial thing your sleepy brain notices is that there are many more messy arrangements than tidy ones. If you randomly toss socks and books and cables around long enough, you're almost guaranteed to land in one of the countless disordered states, not that one crisp, hyper-organized layout. That's entropy. The system tends to wander into the majority of states, and those majority states are the ones you'd casually call a mess. The same logic applies to air molecules in a room, to coffee cooling in a mug, to dye spreading through water. There are just more ways to be spread out and even then to be bunched up and special. You roll that idea around like a marble. Entropy isn't a gremlin that actively makes things worse. It's a kind of statistics. When you put a cold ice cube in a warm drink, there are far more microscopic configurations where everything ends up lukewarm than configurations where the heat spontaneously flows from the cold cube into the drink, making the cube even colder and the drink hotter. Nothing in the fundamental forces forbids heat going the wrong way. It's just fantastically unlikely, like shuffling a deck of cards and accidentally sorting it perfectly by suit and number. So, your everyday arrow of time, the sense that eggs become omelets and not the other way around, that cream mixes in a coffee and doesn't unmix, comes from his tendency for systems to move from less probable arrangements to more probable ones. Forward in time is the direction in which entropy increases. Backward in time is the direction in which entropy decreases, which is mathematically allowed, but statistically almost absent in ordinary life. The universe, in that sense, behaves like a gigantic machine drifting from special, ordered states toward generic, scrambled ones. But that raises an uncomfortable follow-up, and you feel it settle onto your chest like an extra blanket. If entropy tends to increase, that means it must have been lower in the past. If your bedroom is getting messy over time, that implies it started off more tidy. If the universe as a whole is drifting from order to disorder, then way back, something about it must have been unbelievably ordered compared to now. Your arrow of time is built on that assumption, whether you knew it or not. Your thoughts zoom out to cosmic scales again. You picture the early universe as that hot, glowing plasma you met before, everything squeezed into a dense, nearly uniform fireball. At first glance, that doesn't sound ordered at all. It sounds chaotic, unimaginably hot, particles flying around, everything smashed together. But the trick here is gravity. With gravity in the mix, a uniform distribution of matter is actually a very special, low-entropy state. Most ways of arranging a lot of mass in a big volume involve clumps, clusters, black holes, collapsed structures. A perfectly smooth universe is like a perfectly shuffled deck in reverse. It's the weird, finely tuned arrangement, not the typical one. That's the weird punchline. The early universe was, in a precise technical sense, extremely simple and smooth compared to what it could have been. The cosmic microwave background, the faint afterglow of that early fireball, shows you this in a kind of fossilized photograph. When you look at it with a radio telescope, you see a nearly uniform temperature with tiny little ripples in brightness. Those tiny ripples are the seeds of all the structure you see now. Galaxies, clusters, stars, planets, you. But overall, that ancient snapshot is astonishingly even, like a sheet that's been stretched almost perfectly flat across the whole sky. From the standpoint of entropy, that smoothness is shockingly special. The universe had many more ways to exist that would have looked wildly inhomogeneous, already full of black holes and dense knots. Instead, it started in this very low entropy condition and has been slowly climbing up the entropy ladder ever since, forming stars, burning fuel, creating pockets of complexity like your brain. The arrow of time you feel, the reason your memories are oriented in one direction, is connected to that original, improbably neat initial configuration. You let that idea sink in, and it's almost funny in a cosmic way. Here you are, lying in bed, feeling guilty about a messy room or a cluttered inbox, and the universe itself has a kind of embarrassing backstory. Once upon a time, it was absurdly tidy. All the disorder you see now, chemical chaos in your cells, heat leaking into space, galaxies colliding, has been built on that hidden past hypothesis, the assumption that the universe began in a state of extraordinarily low entropy. The real mystery, the one that keeps nagging at you, is why it started that way at all. The equations of physics don't seem to demand such a pristine beginning. They're mostly happy running backward or forward. You could imagine a universe where entropy is already high in both time directions, a forever messy cosmos where no one can tell which way the story goes. But that's not the universe you live in. Yours seems to have a special boundary condition in the past, a clean starting line from which the race toward disorder has been running for billions of years. Some thinkers imagine that low entropy beginning as a kind of rule layered on top of the other laws, a cosmic initial instruction that simply says, start here, in this incredibly simple state. Others suspect there might be a deeper explanation. Maybe the strange smoothness of the early universe comes out of some unknown principle or some more fundamental theory in which what looks fine-tuned now is actually natural. Still, others shrug and treat it as a brute fact, something you notice and quantify, but don't really explain, like the color of the universe's eyes. Whatever the explanation, the consequence for you is very personal. Your own sense of before and after, your memories and expectations, your feeling that tomorrow can still surprise you while yesterday is fixed, are all tied to this cosmic asymmetry. If the universe hadn't started in such a special, low-entropy condition, you probably wouldn't be here to worry about it. Ordered beginnings make room for structures like your nervous system to develop, to store information, to maintain patterns against the tide of increasing entropy. The arrow of time isn't just out there. It's woven into your biology. You let your imagination do something playful. You reverse the film of the universe in your mind. Stars unexplode, supernovas inhale their own debris, shattered planets reassemble, waves fall upward toward raindrops that rise back into clouds. People walk backward into hospitals and become smaller, lighter, less wrinkled, eventually sneaking back into wombs. Broken coffee cups leap up from the floor, shards fusing into smooth ceramic, while spilled coffee flows neatly into the mug. Nothing in the fundamental equations forbids that bizarre world. You're just looking at a trajectory where entropy decreases instead of increases. Yet you find that reversed world strangely creepy. It doesn't feel like a real alternative. It feels like a nightmare logic that violates something deep in your gut. That feeling isn't proof of anything, but it lines up with the statistics. In the space of all possible histories the universe could trace, the paths where entropy goes up are overwhelmingly numerous compared to the ones where entropy goes down. Your familiar arrow of time isn't a moral law. It's just what happens almost always, given that special low-entropy launch. As you think about this, your awareness drifts back to that first fraction of a second after the Big Bang. Whatever happened there, whether it involved inflation, weird quantum states, or some even stranger geometry, it set the stage for everything that followed, including the fact that you experience time the way you do. The early universe wasn't just hot and dense. It was delicately tuned in a way that allowed an arrow of time to exist at all. If it had been born already maximally disordered, there would be no slow unfolding, no habitable eras, no long chain of cause and effect leading to you wondering about it under your blanket. You realize that the question, why does time flow the way it does, is tightly knotted with, why did the universe begin in such a special state? Pull on one thread and you tug the other. To really answer where your arrow of time comes from, you'd have to talk about the very beginning, or whatever plays the role of beginning in the correct theory. Maybe that's a sharp boundary. Maybe it's a bounce from a prior phase. Maybe before simply stops making sense when you zoom in far enough. For now, though, you let yourself just rest with the puzzle instead of trying to solve it. Time's arrow points from low entropy to high, from simple to complex, from that smooth, early plasma to the clumpy, star-filled sky above you tonight. You're somewhere along that slope, a temporary pattern that can think and remember, built out of matter that was once nearly featureless. The very fact that you can lie here and reflect on a low-entropy past is part of the story of entropy increasing. Cosmic order made you, and cosmic disorder will eventually erase you. But in between, there's this strange, bright interval where the universe knows it has a history. That thought again nudges you toward the inevitable next curiosity. If the arrow of time is rooted in the universe's initial condition, what should you even mean by before that condition? Does it make sense to imagine a time before time's arrow, or a phase where the usual ideas of earlier and later simply melt away? As that question forms, you feel your mind turning toward even more speculative ideas. Bouncing universes, quantum beginnings, timeless states, places where the word nothing stretches and snaps. You don't have to go there yet, but you can feel the edge of it, inviting you to step a little closer. That question you felt tugging at the end of the last section doesn't go away. If the arrow of time you live inside is tied to the universe's special beginning, what on earth are you supposed to do with the words before the beginning? You're lying there in the dark, and your brain is trying to poke past the edge of the map. It's a bit like walking down a hallway and finding not a locked door, but a painted wall where a doorway should be. Your language almost insists there has to be something on the other side because you're so used to everything having a before. You notice how deeply built in that idea is. You had a day before this one, a childhood before that, generations of people before you, stars and galaxies before those. Every story you've ever heard has a once upon a time, some starting point that could always, in principle, be pushed back. Your mind is addicted to that pattern. So when someone says, the universe began 13.8 billion years ago, a quiet, stubborn part of you immediately answers, okay, but what was going on the day before that? Physics, annoyingly, doesn't always answer in the way your story-loving brain expects. According to general relativity, the theory that describes gravity and the shape of space-time, if you rewind the expansion of the universe far enough, you eventually hit a point where the equations blow up. Densities and temperatures go to infinity, space-time curves so sharply that the math just stops making sense. That edge is what people usually mean by the Big Bang singularity. It's not a tiny marble of actual physical stuff. It's a sign that the theory you're using has reached its limit and is now just yelling error messages at you. One famous response to the question, what happened before the Big Bang, was basically, the question doesn't make sense, a bit like asking, what's north of the North Pole? If time itself is part of the thing that began, then before might simply not apply. Your mind bristles at that because it feels like a trick, but imagine again your globe. You can walk north until you hit the top. Past that, north isn't a direction you can keep going. The Earth's surface just doesn't support the idea. Maybe time is like that near the beginning. You can follow it backward until you hit a kind of pole, and beyond that, the concept of earlier just dissolves. Still, not everyone is satisfied with that answer, and you feel why. It's conceptually neat, but emotionally unsatisfying. So your thoughts drift into more speculative territory, where physicists let their imaginations run, guided by math instead of Netflix. You find yourself picturing a universe that didn't simply begin, but bounced. The bouncing universe idea is surprisingly intuitive when you let it into your mind. You've rewound the cosmic expansion in your head before, watching galaxies pull together like beads on an elastic string. This time, you imagine continuing to rewind all the way until everything is squeezed into something unimaginably dense. In one version of the story, that crushing phase is a previous universe contracting under its own gravity, shrinking smaller and smaller like a slowly deflating balloon. Eventually, it doesn't just end in a singularity. The pressure and quantum effects combine to force a rebound, a big bounce. In that picture, what you call the Big Bang is not the beginning of everything, but the turnaround point between a prior contraction and the expansion you live in now. Time wouldn't stop at the bounce. It would just change direction for the size of the universe. Before your bang, a different cosmos might have been growing old, cooling down, forming stars and galaxies, possibly even life, all drifting toward a big crunch. Then, instead of the movie ending in a catastrophic freeze frame, the story flows straight through the crunch into the bounce, and out the other side into your current era. Your mind plays with that like a kid with a new toy. If the universe can bounce once, could it bounce over and over? Could there have been an endless sequence of universes, each expanding and contracting, like lungs breathing in and out on a timescale, so vast it makes human history look microscopic? Maybe entropy resets or dilutes in a clever way at each bounce, so that each new cycle gets its own low-entropy fresh start and its own arrow of time, pointing away from the bounce in both directions. Of course, you also remember that not all versions of this idea work nicely with the data. A simple, perfectly repeating cycle tends to run into problems with entropy piling up from one era to the next. That's the thing about disorder. It doesn't like to vanish. To make cyclic or bouncing models fit what we see in the sky, theorists have to give them more complicated mechanisms, ways for entropy to leak out, or for space to stretch so much that each new cycle wipes the slate clean enough to start over. These models are clever, but they sit in the maybe folder, not the we're sure one. Still, the very existence of bouncing universes in the conversation loosens your grip on that rigid question, what was before? It suggests that before might look very different from after, but still be part of the same overall story. A contracting predecessor, a collapsing cosmos that hands off its energy to a fresh expansion, has a poetic symmetry to it. You picture two universes passing through each other like acrobats flipping in midair, one collapsing, one exploding outward, both sides sharing the same narrow instant of the bounce. You don't have to marry the bouncing idea, though, because your thoughts are already wandering further into the realm where quantum mechanics starts bossing gravity around. You've seen how quantum fields make the vacuum lively, how tiny fluctuations in the early universe seeded everything you know. Now you picture the whole universe itself as a kind of quantum object subject to jittery possibilities and strange rules. At very small scales, the comforting continuity of space-time starts to break. According to many physicists, you can't really talk sensibly about distances and times below some tiny limit, because quantum uncertainty makes everything too fuzzy. Space and time might dissolve into something more like a frothy, restless quantum foam, where geometry is constantly twitching, too unstable to behave like the smooth stage you're used to. In that kind of regime, asking, what was the universe doing a trillionth of a second before the Big Bang, might be as meaningless as asking what a wave was doing at a point smaller than its own wiggles. One class of ideas treats the birth of the universe as a quantum event, something like a particle tunneling through a barrier in quantum mechanics. In ordinary life, you can't walk through walls, but in the quantum world, particles constantly do the equivalent of that, slipping through energy barriers they don't technically have the oomph to cross, because the rules are probabilistic rather than rigid. Some cosmologists picture the universe doing that on a grand scale, tunneling from a state with no classical space-time into a tiny, rapidly inflating bubble, which then grows into everything you see. Here, nothing becomes a dangerous word again. The nothing in these models isn't literally the absence of all rules, logic, and possibility. It's more like no ordinary space and time, but still some kind of underlying quantum structure or law. You're not talking about absolutely nothing. You're talking about a different kind of something that doesn't look like a place with clocks and rulers. The universe might have emerged from a state that has no ordinary notion of before and after, and yet, from that strange quantum background, a classical space-time like yours can spontaneously appear. Your sleepy sarcasm perks up a little. So we came from nothing, but also not really nothing, just a weird kind of something that we call nothing because it makes a good book title. That's not entirely unfair. When people say the universe came from nothing with a straight face, They usually mean it came from a state that isn't a previous universe in the normal sense. No stars, no space, no ticking cosmic clock, but they're still assuming some kind of mathematical framework, some laws that allow a universe to pop into existence with a certain probability. Other ideas go even further and start messing with time itself. Instead of imagining a before and after situation, they treat time as something that emerges from a deeper, timeless reality. You picture a complete novel, printed and bound, sitting on a shelf. The entire story exists at once. First page, last page, every twist in between. But when you read it, you experience the plot as a flow, as a sequence. You don't see the whole thing at once. You turn pages in a particular order, and that order becomes your personal sense of time moving. Some physicists and philosophers think the universe might be a bit like that book. The whole four-dimensional space-time, past, present, and future, might exist in a single frozen block, a block universe, where nothing really happens in the way you imagine. What you call the passage of time is your brain walking along one thread of that block, experiencing one slice after another. In that picture, asking what was before the Big Bang is like asking what's earlier than the first page of the book. The answer might just be, there is no earlier page in this story. The story simply starts there. Another timeless view suggests that at the most fundamental level, the universe is described by a static quantum state, a kind of cosmic chord that contains all possible configurations at once. Within that state, subsystems can act as clocks for each other. One part of the universe evolves relative to another, and from within the system, it feels like time is flowing, even though the underlying description never changes. From that angle, time is a convenient story the universe tells itself, not a basic ingredient of reality. You can feel your brain starting to wobble a bit under all of this. Bounces, tunnels, timeless blocks, it's a lot. But notice something important. In every one of these pictures, the word before is being reshaped. In a bouncing cosmos, before might mean a prior phase of contraction. In quantum beginning models, before might be replaced by outside, as in some timeless quantum backdrop that occasionally spits out universes. In block or timeless models, before might simply not apply, because the whole history is already there, laid out like a finished map. And here you are, a little creature who evolved to track sunrise and sunset, to remember where the food is, to plan for tomorrow's meeting, trying to wrap your head around whether time itself might be emergent or limited or just a useful illusion. It's almost impressive that your brain can even gesture in these directions, even if it can't fully picture them. You roll onto your side, feeling the weight of the covers and the softness of the pillow, and you let yourself admit that these ideas are speculative. The early universe hides its secrets behind extreme conditions you can't recreate in full. Your telescopes see light from long ago, your equations extrapolate back, but right at the edge, where densities are wild, where quantum gravity takes over, you're still guessing. Educated guessing, guided by math and observations, but guessing all the same. Oddly, that doesn't have to be frustrating. It can be soothing. Humans have always told origin stories, from gods wrestling chaos into order to cosmic eggs cracking open. Now you're telling a story with bounces, quantum foam, and timeless states. The names have changed, the details are sharper, but the emotional pattern is the same. You're standing at the limit of what you know, peering over and wondering whether the ground continues or turns into mist. What ties all these ideas together is that none of them give you a simple, everyday before. The Big Bang is not just a bomb going off in an empty room. It's either a boundary in time, a transition from a previous phase, a quantum event out of a strange backdrop, or a special slice in a timeless hole. In every case, your habitual calendar-based way of thinking about earlier and later has to be stretched until it almost snaps. As that realization settles in, you feel the next question already forming at the edge of your awareness. If there might be bouncing phases or quantum births or timeless backdrops, Could there also be other universes, other bubbles, other branches where things turn out differently? Could the story you're in be just one version among many? One bubble in an endless cosmic soda? The thought hangs there with you in the dark, like a door you haven't opened yet, quietly waiting for you to step through. You've been standing at that doorway in your mind, the one that opened at the end of the last section when you realized before the Big Bang might not be as simple as flipping a calendar page. Now you gently nudge it open a little farther, and something even stranger spills out. The possibility that this universe, the one holding your bed and your breathing and your thoughts right now, might not be the only show in town. It starts with a picture you've already carried in your head. Space expanding, galaxies rushing away from each other like dots on an inflating balloon. Earlier, you imagined rewinding that balloon until everything squeezed together in a dense, hot beginning. This time, you imagine the inflation itself going wild, not just as a brief early phase that switched off neatly, but as a process that keeps going in some regions even while it ends and cools in others. In some theories, space doesn't just expand, it inflates at a runaway rate in certain patches, driven by a field with high energy. That inflating background is like a pot of boiling water, except instead of bubbles of steam, you get bubbles of normal space, regions where inflation slows down, energy turns into particles, and a hot Big Bang happens. Your universe, the one you live in, would then be just one bubble in a vast, possibly infinite cosmic foam. You can almost see it, a dark, roiling backdrop of inflating space, unimaginably stretched, where little bubbles keep appearing, growing, cooling, and filling up with galaxies. Each bubble is its own universe with its own story. The expansion between bubbles is so fast that no signal can ever cross the gaps. From inside, each bubble feels alone, complete, and self-contained. The stars in your night sky are just the local decorations of your particular bubble, not the whole showroom. The wild twist is that the rules inside each bubble might not be identical. The laws of physics in their deep form could be universal, but the specific settings they settle into, numbers like the strength of gravity, the masses of particles, the amount of dark energy, might vary from bubble to bubble, like different outcomes in a cosmic dice game. You, lying there under your blanket, might be living in one of the rare bubbles where those settings happen to be just right for stars to last billions of years, for chemistry to get interesting, for life to slowly assemble itself out of stardust. Think of it like walking into a gigantic arcade full of machines, each one running the same game, but with random difficulty settings. On most of them, the obstacles are impossibly fast, the timer is too short, or the controls barely work. Nobody could play long enough to get good at it. But on a few machines, by chance, the settings line up just so, and players can actually reach higher levels, explore the world, and enjoy the story. You just happen to wake up at one of those lucky machines. This idea leans on something you might have heard in a more formal way. The universe looks oddly fine-tuned for life. If gravity were a bit stronger, maybe everything would have collapsed quickly into black holes. If it were weaker, perhaps structure would never have formed and the cosmos would just be a thin mist. If the amount of dark energy that speeds up expansion were much larger, galaxies might have been pushed apart before they could even gather. The ranges that allow long-lived stars, complex chemistry, and quiet little planets with liquid water are surprisingly narrow. From inside a single universe that can look suspicious, almost like cheating. Why do these numbers, the ones buried in equations you never see, but that decide whether you ever get a sky at all, fall into a range that lets you be here to complain about the weather? One answer is, well, maybe there's a deeper law that forces them to be this way. Another answer, the multiverse-flavored one, is maybe there are countless universes with all sorts of settings, and you're obviously in one of the rare ones that works, because where else could you be? That reasoning has a fancy name, an anthropic principle, but the core idea is almost annoyingly simple. Observers only find themselves in places compatible with their existence. You don't wake up in a universe where stars never formed, Not because such a universe is impossible, but because there's no one there to wake up and ask questions. It's like walking into a library where most of the books are filled with random letters that never form words. The only books you can actually read are the very rare ones where the letters line up into coherent sentences. So of course you're surprised to find yourself holding a book that makes sense until you realize you couldn't have held the gibberish volumes in any meaningful way. Not everyone loves this answer. Some people find it elegant, a neat way to explain apparent fine-tuning without smuggling and hidden purpose. Others think it feels like a cosmic shrug. We're here because if it were different, we wouldn't be here. Thanks for coming to my TED Talk. You can feel both reactions wrestling quietly in your mind. On one hand, you understand that selection effects are real. On the other hand, your curiosity still wants more than "you won the cosmic lottery, congrats." And the idea of that cosmic lottery only gets stranger when you add in another flavor of multiverse, the quantum one. Earlier, you listened to how quantum fields buzz in the vacuum, how particles and waves blur together into probabilities. In that framework, when a quantum event has multiple possible outcomes, it isn't that one of them really happens and the others vanish. It's that the overall quantum state encodes all the possibilities at once. One way to interpret this is the many-worlds picture, where every outcome gets its own branch of reality. Imagine you're about to measure whether a particle's spin points up or down. According to many worlds, the universe doesn't pick one and discard the other. Instead, the universal wave function evolves in such a way that there are now two versions of the measuring setup. In one branch, you see up. In the other, you see down. Both branches are real in the math, but they no longer interact. From the inside, each version of you feels like there was a single outcome, because you only ever experience one branch at a time. Extend that branching process to every quantum event that ever influenced anything macroscopic, and you end up with a truly enormous tree of histories. In some branches, certain stars explode earlier, planets form differently, or evolutionary paths take other turns. In a tiny subset of branches, you exist as you are now. In countless others, you never do. There too, you're a kind of selection effect. You find yourself inhabiting a branch where the chain of accidents produce someone who can lie in bed and worry about the wave function. It's important to notice that this quantum multiverse is different from the bubble one. Many worlds is about branching within one overall mathematical structure, with the same fundamental laws and constants everywhere. The paths just diverge based on outcomes. The bubble multiverse is about separate local regions of space-time with potentially different physical parameters. One is more like alternate timelines in a giant decision tree. The other is more like separate game cartridges loaded with different difficulty settings. Both are dizzying. Both, at least so far, hide behind layers of math and indirect hints, rather than waving at you from the night sky. If you're still with me, and I suspect you are, if only because your body is too comfortable to move, you might be wondering how far this rabbit hole goes. Some approaches to quantum gravity and string theory suggest there could be an enormous landscape of possible vacuum states, each corresponding to a different way the basic ingredients of reality can settle down. Each vacuum would imply a particular set of low-energy laws, which particles exist, how forces behave, what the vacuum energy is. If eternal inflation is happily creating new bubble universes all the time, it might sample that landscape, generating bubble after bubble with different rulebooks. From that angle, your universe is something like a habitable valley in a vast, rugged terrain of possibilities. Most valleys are barren. No long-lived stars, no stable atoms, no chemistry beyond a brief flicker. A few precious valleys have just the right properties to host complex structures. You happen to live in one of those rare, fertile pockets. Again, you shouldn't be shocked to find yourself in such a place. An uninhabitable valley wouldn't contain you. You might notice a pattern here. Every time the laws of nature seem oddly convenient for life, one possible move is to say, Perhaps there's a deeper reason we don't know yet. Another move is to say, perhaps there's a huge ensemble of possible realities, and we're inside one of the tiny subset where life works. The multiverse is that second move turn up to maximum volume. Of course, the awkward question lurking in the dark is, can you ever actually test this? Can a universe sealed inside its bubble ever prove other bubbles exist? Can branches of the wave function, forever separated, leave fingerprints that tell you they're out there? Some proposals suggest subtle signatures, like scars in the cosmic microwave background from bubble collisions, or constraints on inflationary models that imply eternal inflation is likely. Others think that if a theory that predicts a multiverse also accurately describes everything you can observe in your own bubble, that might be as close to a test as you'll get. Still, it's fair to say you're now wandering near the edges of what science can comfortably talk about. You lie there and let this sink in. It is entirely possible that most of reality, if such multiverse ideas are right, will always be out of reach. There could be vast expanses of space-time beyond your horizon, bubbles upon bubbles, histories upon histories, and you will never see them. Your telescopes, those delicate, expensive extensions of human curiosity, can only drink in a finite patch of sky. No matter how clever you get, light has a speed limit, and the universe has only been around for so long. In a way, though, that limitation is part of the charm. It means there will always be mystery. Even if the multiverse concept turned out to be wrong, the sheer scale and complexity of this one universe are enough to keep minds busy for as long as there are minds. But if some version of the multiverse is right, then the richness of reality is almost indecent. You're not just living in a big universe. You're living in one branch of one bubble in an ocean of possibilities, one configuration where the rules landed in a way that allowed coffee, memes, thunderstorms, and late-night existential YouTube channels. You might think that should make you feel small, and maybe it does for a moment. You, your bed, your entire planet. It's all just a tiny localized phenomenon in a remote bubble. But stay with that feeling a bit longer, and something else appears underneath. Somehow, despite the absurd odds and the indifferent math, there's a pocket of reality where hydrogen fused into heavier elements, where planets cooled, where life climbed out of chemistry, and where a brain like yours can wonder what on earth nothing means. Out of all the ways things could have been, you're in one where questions like this can even be asked. That's the lucky rules part of the story. Whatever the deep reason, multiverse, deeper law, or something you haven't even imagined yet, the particular combination of constants, forces, and initial conditions in your bubble has given rise to this moment. To you here thinking, the universe didn't have to write a chapter that contains language, music, and curiosity. Yet it did, at least once in at least one place. So when you hear phrases like just a random fluctuation or just an anthropic selection effect, remember that the word just is doing a lot of emotional work. Even if the explanation is as bland and mechanical as that, the result is anything but bland from the inside. From your point of view, the numbers that set the stage for reality are not merely parameters in equations. They're the quiet conditions of your own existence. You let that awareness spread out a little like ink in water. Multiverses, bubble worlds, branching histories, they're all attempts to make sense of why anything is here and why the anything that's here has this particular flavor that allows minds like yours. Whether there are countless other versions that will never know you exist, or whether this is the only universe there ever was, your experience of it is still completely unique. No other patch of reality will ever see the cosmos from exactly your angle, with your memories and your private colors and your oddly specific playlists. Somewhere, deep in the math, there might be ensembles of universes, measures over possible worlds, probability distributions over constants. But for you, tonight, it comes down to something very simple. There's a sky above you, even if you can't see it through the ceiling. There are galaxies scattered like sparks in a dark wind, and there is you, a small, localized storm of atoms, quietly trying to understand the rules of the game that made you possible. And as your thoughts linger on that, you can feel the next piece of the puzzle lining up almost on its own. If multiverses and lucky rule sets and branching histories are even remotely on the table, then your own consciousness, this strange, bright knot of awareness that's asking these questions, starts to look less like a footnote and more like the universe's most surprising plot twist. That most surprising plot twist you were just picturing? It isn't some alien civilization or a hidden dimension. It's much less dramatic on the outside and way stranger on the inside. It's you. This bundle of cells with a slightly stiff neck and a half-remembered to-do list, lying here in the dark, quietly constructing an entire universe inside your head. All that talk about multiverses, bubbles, and lucky rule sets eventually runs into a very local fact. Somehow, in this particular bubble, in this particular galaxy, on this particular planet, a patch of matter woke up and started asking, where did all this come from? So you let your attention slide gently inward. Not to your thoughts yet, just to the very basic fact that you exist at all. There's a weight on the mattress, a warmth under the blanket, a rhythm in your chest that's been going since before you ever knew the word heart. You're made of atoms. Unromantic, standard issue, Big Bang approved atoms. Hydrogen from the early universe. Carbon forged in stars. Oxygen, nitrogen, iron, calcium, all cooked and recycled through generations of exploding suns and merging clouds. By the time your body assembled, those atoms had already been through a billion-year drama you will never see. And yet here they are, quietly working overtime so you can complain about your Wi-Fi speed. If you could rewind the story of just one atom in your brain, you'd see a cosmic travel vlog no influencer could compete with. Picture a lone hydrogen nucleus born in that early hot plasma when the universe was only a few minutes old. At first, it's just floating in a glowing soup, bumping into other particles like someone stuck in a very crowded metro train made of light. Eventually, space expands, things cool, and it drifts inside a gas cloud, then into another, then gets swept into a collapsing region that will become a star. Maybe it spends a few billion years in that star's outer layers, occasionally getting kicked around by radiation, before being blown back into space when the star swells up or sheds its outer shells. It joins new clouds, new cycles, maybe orbits in some icy dust, and finally, after an absurd chain of accidents, it becomes part of a molecule that gets folded into a cell in your developing brain. And now, that same atom is helping build the electrical potential that lets one of your neurons fire, which helps support the thought you're having at this exact second. 13+ billion years of cosmic wandering, just to help you wonder if the Big Bang came from nothing. The universe took a very long detour to generate the sentence currently echoing in your mind. The more you think about it, the fuzzier the line between you and the rest of the universe becomes. Your skin feels like a border, but it's more like a semi-permeable negotiation. Air moves in and out. Heat flows. Photons bounce off your retina and get turned into mental images of stars, or of your phone screen, or of the same ceiling you've stared at 1,000 times. Every ingredient in your body came from outside, stays on loan for a while, and will eventually wander off again. You're less a separate thing and more a temporary pattern, a brief arrangement of matter and energy that happens to be self-aware. That self-awareness feels huge from the inside. It feels like a main character role. There's a voice in your mind that narrates, comments, judges, worries, remembers that embarrassing thing from years ago, and replays it for no good reason. That voice can sound like you, but under the hood, it's just a particular way this pattern of atoms is processing information. Neurons firing, chemical gradients shifting, signals looping through circuits that evolved to keep a squishy animal alive long enough to pass on its genes, and accidentally invented philosophy on the side. From the outside, it's just physics. Tiny charges moving across tiny gaps, molecules binding and unbinding. But from the inside, it's taste and sound and memory and shame and joy. It's the feeling of a warm mug in your hands, the smell of rain, The way a song from years ago can suddenly pull a whole era of your life back into focus. Same underlying rules, completely different experience. Someone reading the equations would see nothing but fields and interactions. You, living as a small patch of those fields, experience them as a whole world. And that brings you back to the question that started this night. Did it all come from nothing? It's weirdly fitting that such a question would emerge from a system like you. You're built to detect patterns, to notice causes, to ask what came before. It's your brain's survival software. If there's a rustle, you want to know what caused it. Wind? Predator? Neighbor doing something suspiciously loud at midnight? You're wired to chase explanations. So when you look up at the cosmic rustle, the expansion of galaxies, the glow of the cosmic background, the whole Big Bang story, your brain naturally asks, okay, but what caused that? The strange part is that the brain asking that question is itself a product of the very process it's interrogating. Your curiosity isn't hovering above the universe, judging it from a safe distance. It's made from a universe. The urge to ask why is an emergent property of matter that cooled, clumped, and evolved under the rules we've been talking about all night. When you trace the chain back from your late-night wondering to your neurons, to their atoms, to the Big Bang, you get this almost comedic loop where the universe becomes complex enough to question its own origin and then genuinely seems confused by itself. There's a kind of gentle sarcasm hiding in that. The cosmos spends billions of years fusing hydrogen into heavier elements, building galaxies, sculpting planets, evolving life through countless generations. And the end result is you lying there at some ridiculous hour, half sleepy, asking, so did we come from nothing or what? It's like building a supercomputer and the first thing it does is overthink its own instruction manual. And yet, that's the part that makes your existence feel oddly precious. Multiverses and bubble worlds are grand, but they're also impersonal. They're about distributions and probabilities and ensembles. You, on the other hand, are ridiculously specific. You are one exact arrangement of atoms, with one exact collection of experiences, memories, and weird habits. No other patch of reality, in any bubble, in any branch, will ever be this precise configuration again. The laws might be universal, but the way they play out here, in this body, in this mind, is one-off. So when you think about the Big Bang and about nothing, you're not just doing abstract cosmology. You're doing autobiography on a cosmic scale. You're essentially asking, where did I come from? And just extending the eye outward, step by step, until it includes the whole observable universe. First, it's, where did my life come from? Then, where did life on Earth come from? Then, where did the elements come from? And eventually, where did space-time and its rules come from? It's the same question, zoomed out. This shift from seeing yourself as a tiny spectator to seeing yourself as a temporary local expression of the universe changes the emotional tone of that question. Instead of feeling like you're peering into a cold, distant puzzle, it starts to feel like you're reading a family secret. You're trying to understand your own origin story, not just the origin story of some anonymous cosmos out there. It also sneaks up on your worries in a quiet way. All the day's stress, emails, deadlines, money, relationships, whatever your brain likes to juggle, sits on top of this deeper backdrop. You're not trying to use cosmic perspective as a cheap, your problems don't matter trick that usually just adds guilt on top of stress. It's more like realizing that your problems are happening inside a much larger, older process. They're real, but they're not the whole story. They're like small waves on the surface of a very deep ocean. That ocean has been here for billions of years and will be here long after those particular waves have passed. You're allowed to feel them, but you're also allowed to feel the depth beneath them. You can even, for a moment, let go of whether nothing is the right word for what came before or underneath the Big Bang. Instead, you hold on to this smaller, more immediate fact. Whatever the ultimate answer is, it produced a universe where stars form, planets coalesce, life evolves, and eventually some primate descendants invent beds, indoor plumbing, and the ability to stream long, soft-spoken videos about cosmology. That alone is already so unlikely that calling it something from nothing almost feels like an understatement. And tucked inside that is you, this small corner of the universe that can step outside its own thoughts just enough to notice them, to watch them rise and fall like weather, to say, that's interesting, even about confusion itself. You don't need to solve the entire riddle to appreciate how strange it is that you're even here to hear it. The question, did it come from nothing, might never get a tidy, final answer, but the fact you can ask it, feel it, and sit with it is already a sort of answer about what kind of universe this is. You let that realization settle a little deeper. You are the cosmos, temporarily configured into a human life, pausing at night to wonder what the cosmos is. The boundary between the two is not a wall. It's more like a thin mist your mind paints to keep things manageable. On one side of the mist, there's me and my day and my worries. On the other side, there's universe and gravity and Big Bang. But the mist itself is just another pattern the universe is doing. Pull it back slightly, and there's only one process, one continuous unfolding from the early plasma to this quiet room. Somewhere inside that continuity, a question is forming, and it feels more personal now. Not just did everything come from nothing, but what does it mean for me that I came from that same source? You can feel that question beginning to turn slowly from pure curiosity into a kind of gentle comfort. And as it turns, the stage is set for one last step. Taking everything you've seen tonight, vacuum fields, big bangs, fine-tuned rules, multiverses, and this fragile spark of awareness, and asking very softly what kind of answer you really need in order to rest. That last question you felt forming about what kind of answer you actually need to rest is still hanging in the air, quiet and patient. You've come all this way, from everyday empty rooms to quantum vacuums, from exploding stars to multiverses, from anonymous space-time to this very specific moment in your very specific body. It would be nice, your brain thinks, if the universe could now step forward, hand you a neat little card, and say, here you go, final answer. Yes, it all came from nothing, or no, it definitely didn't. But that's not how this works, and some part of you already knows it. You go back, gently, to that word you started with, nothing. It sounds simple, but by now you've seen it has layers like an onion. Except every time you peel one back, there's another underneath, smirking at you. At the surface, there's everyday nothing. The empty glass, the cleared-out inbox that stays empty for about 30 seconds. The room with the furniture moved out. That kind of nothing was never really nothing at all. There were still air molecules, photons, gravity pulling on everything, a building holding the room up, a planet under the building, and a universe wrapped around the planet. Then there was physics nothing, the vacuum with no real particles in it, just fields in their lowest energy states. That sounded closer to what you wanted until it didn't. Because that vacuum still had rules. It still had quantum fields humming quietly, still had space-time, still had a way for energy and momentum and all the rest to be accounted for. It could be unstable. It could fluctuate. It could, at least in some models, give birth to expanding regions that look a lot like universes. That's not nothing. That's a very clever something wearing a minimalist outfit. You might even picture it now. Some kind of bare-bones stage, no props, no characters yet, just the lighting rig and the sound system and a blank script template waiting in the background. Physics nothing is like that. There are no actors on the stage, but there's still a theater, still directors, still a set of rules saying what counts as a performance and what doesn't. If a universe pops out of that, you can't honestly say it came from nothing. It came from a rule book and an arena that were already there, even if they were as stripped down as possible. And beneath that, there's the deeper philosophical nothing. No space, no time, no fields, no laws, no maths quietly waiting in the wings. No stage, no theater, no director, and not even the concept of story. That's the nothing people usually mean when they really push the question, why is there something rather than nothing? They're asking why there's a stage at all, why there are any rules, why there's anything that can be described, noticed, or lived. Here, all your clever physics tools start to slip through your fingers. Equations that describe fields and vacuums presuppose that there's already some kind of structure to describe. The question of why there's any structure at all isn't just hard. It might not fit into the kind of answer your mind evolved to handle. You're great at what caused this, when this is a sound, a movement, a storm, a broken glass. You're less equipped for, why is there a system in which causes can even exist? And yet, lying here, you can still feel the pull of it. Did we come from nothing, or from something disguised as nothing, or from rules that somehow just are, needing no further explanation? Was there a multiverse foaming away forever, bubbling out universes like ours now and then, so that asking, why this one, is a little like asking why this wave in the ocean? Did some deeper, timeless reality stir in a way that made space-time itself appear, so that before is the wrong word, and your question is like asking, what's north of the North Pole? You can parade the options gently in front of your mind without trying to pin any of them down. Maybe the total energy of the universe really is zero in some clever sense, with positive energy balanced by the negative energy of gravity, making the whole thing more like a cosmic loan that nets out to nothing on the books. Maybe quantum cosmology will eventually show that once you have a certain kind of mathematical structure, universes like ours are not just possible, but inevitable. Maybe there really is a sea of bubbles, each with different laws, and you just happen to be in the one that supports chemistry, brains, and the urge to start podcasts. Or maybe every one of those ideas still dodges the deeper question, and the true answer is simply, there's something rather than nothing, and that's all we know, and maybe all we can know. What you notice as you let these thoughts roll past is that your emotional response to them has softened. Earlier in your life, a question like this might have felt sharp, like a puzzle you were somehow failing to solve, or a glitch in the universe's explanation system. Now it feels more like standing at the edge of a quiet lake at night. You can't see the bottom, and you don't need to. The surface is enough. The reflection of the stars is enough. The fact that the lake is here at all is already astonishing. You think back to all the pieces of the story you've touched tonight. The vacuum that isn't empty, the early plasma, the quantum fluctuations stretched by expansion, the improbable chemistry that led to life, the neurons that turn matter into mind, the multiverse ideas that may or may not be true, but at least give you new ways to imagine the whole thing. Whether or not we came from nothing, it's clear that we came from an outrageously fertile something, a set of conditions that allowed complexity to bloom in ways that still surprise the creatures living inside it. And you're one of those creatures. So when you ask, did we really come from nothing? You can now hear a quieter, more nuanced echo. We came from a universe that behaves as if it is deeply structured, governed by rules that let atoms form, stars ignite, planets cool, and consciousness emerge. If there was a deeper nothing beneath that, it's hidden behind layers of mystery we haven't peeled back yet, and may never peel back completely. The strange part is that you don't actually need to resolve that final layer to live a meaningful, vivid life inside this one. You don't need to know whether the ultimate ground of being is a quantum vacuum, a timeless equation, a multiverse, or some reality so different that all these words bounce off it. You already know enough to feel the weight and wonder of existing at all. You know that you're made of the same stuff as stars, that you're seeing and thinking are ways the universe sees and thinks, that the laws are reliable enough for you to plan breakfast tomorrow and wild enough to produce galaxies and black holes. If the universe did somehow come from nothing, that nothing must be more like a hidden potential than a blank. If it didn't, and it's just there in some brute, unexplained way, then that just there is the backdrop to every laugh you've had, every person you've ever loved, every ordinary detail of your day. Either way, you're living in something unimaginably rich. The label on the box, nothing, something always from nowhere, doesn't change the taste of the experience from the inside. You can feel the question loosening its grip slightly. It's not gone. It will probably never be gone. It's the kind of question that's supposed to stay open like a window. But now it feels less like a demand and more like a companion. A soft, patient curiosity that walks alongside you instead of tugging at your sleeve. If you like, you can imagine another version of you in another possible universe, lying in a different bed under a different sky, asking a similar question with different words. Or no words at all. Maybe in some bubbles there are no minds to ask anything, and the universe is perfectly content, unobserved, and unquestioned. In this bubble, though at least for now, the universe has grown one U-shaped question mark, stretched out under a blanket, eyes a little heavy, brain still humming. That alone makes this place special. So do we really come from nothing? The most honest answer is, we don't know, and that might be okay. We came from a big bang that we partly understand. We came from fields and particles, from expansion and cooling, from stars and planets and chemistry. We came from causes stacked on causes until they dissolve into something deeper we can't name yet. We came from whatever it is that allowed the possibility of you to appear at all. And here you are. Now the question can stop trying to be a problem and go back to being what it secretly was all along. A lullaby in the language of physics. A gentle rhythm of why, and maybe, and we don't know yet, that rocks your thoughts back and forth until they're calm enough to rest. You don't have to close the book or slam the door on it. You just set it down for tonight, knowing you can pick it up again some other time, in some other mood, and see new things in it. For now, this is enough. You are a tiny patch of the cosmos thinking about itself for a brief moment, in a quiet room, on a small planet, in a universe that may or may not have come from nothing, but has definitely given you this moment. And this moment is real, and it's yours. So let's slow everything down now. Let the big questions fade out to the edges, like distant stars behind a soft, gathering mist. You don't need to follow every thought to the end anymore. You can let them arrive, nod at them politely, and then watch them dissolve into the background. The story has wound its way from the edges of the observable universe to the warmth of your own breathing, and now it's coming to rest, right here with you. Notice how the room feels a little quieter, as if it's exhaling with you. The walls, the ceiling, the familiar shapes in the half-light are all just part of the same universe you've been exploring in your mind. They're close and ordinary and reassuring. You don't have to hold galaxies in your head anymore. You can let them shrink back down into simple points of light, tiny and distant, while your attention returns gently to the rhythm in your chest and the soft weight of your body where it meets the bed. Each breath can be a small reminder. In, there's something. Out, it settles back towards stillness. You don't have to analyze it. You can let breathing become the only thing you care about for a while. Air comes in, air goes out. The universe moves through you in the simplest possible way. Thoughts might still wander toward nothing, everything, before, after, but you don't need to chase them. You can let them float away like small, harmless bubbles rising in a dark pond. If any worry tries to step back onto the stage, some detail from tomorrow, some leftover fragment from today, you can place it gently in that bigger frame you built tonight. It's not erased or dismissed. It's just held inside something wider and calmer. You are allowed to rest, even with unanswered questions. You are allowed to sleep, even though the universe is still mysterious. The cosmos will keep doing what it does without your supervision. You get a clock out for a while. Feel how good it is to let that responsibility go. You don't have to solve the origin of everything. You don't have to fix every problem, understand every law, or tie up every loose thought. You've walked far enough for one night. The rest of the path can wait. Right now, the only job you have is to be here, in this body, in this bed, while the world grows softer and more distant around you. The universe may have come from nothing, or from something we don't yet have words for. But tonight, it has brought you to this gentle pause, this quiet stretch of time where you can sink into stillness and let your mind grow light. Let that be enough. Let it be a small, private answer. Not in the language of equations or theories, but in the way your shoulders relax, the way your jaw unclenches, the way your thoughts slowly thin out until only a calm, spacious silence remains. And in that silence, you can rest.